인류는 끊임없이 도전하는 사람들로 인해 발전해 왔습니다. 국내 1위 도시가스 사업자에서 민간기업 최초로 LNG 밸류체인 완성까지. 여기에 안주하지 않고 우리는 또 다른 도전을 계속하려 합니다. 차별화된 사업 포트폴리오로 만들어가는 지속가능한 미래 에너지 세상. 불가능을 가능으로 바꾸는 도전. 그 여정에 함께해 주세요. SK 이노베이션 ENS가 앞장서겠습니다. 미래 에너지에 답하다. SK 이노베이션 ENS. 인류는 끊임없이 도전하는 사람들로 인해 발전해 왔습니다. 국내 1위 도시가스 사업자에서 민간기업 최초로 LNG 밸류체인 완성까지. 여기에 안주하지 않고 우리는 또 다른 도전을 계속하려 합니다. 차별화된 사업 포트폴리오로 만들어가는 지속가능한 미래 에너지 세상. 불가능을 가능으로 바꾸는 도전. 그 여정에 함께해 주세요. SK 이노베이션 ENS가 앞장서겠습니다. 미래 에너지에 답하다. SK이노베이션 ENS.
세계 수소 엑스포 2025 하이드로전 딥 다이브 퓨처 투 테크의 진행을 맡은 윤희정입니다. 먼저 바쁘신 가운데도 이렇게 많은 분들 함께해 주셨는데요. 진심으로 감사 말씀드리겠습니다. 네, 이번 세션에서는요. 수소 산업의 미래 기술과 신흥 분야를 중심으로 앞으로의 발전 가능성과 변화를 짚어보는 논의가 이어질 예정입니다. 새로운 기술적 전환점을 모색하는 자리인 만큼 참석해 주신 여러분의 의미 있는 시간이 되길 기대하겠습니다. 자, 그럼 시작하겠습니다. 먼저 첫 번째 세션은요. 네, 이산화탄소 등 온실가스를 포접해 미네랄로 전환하는 친환경 탄소 포집 기술을 보유한 이스라엘 기업 에어로베이션인데요. 마야 CEO님을 무대로 모시겠습니다. 큰 박수 부탁드리겠습니다.
I'm kicking the session after the lunch, so it will be challenging. I hope it will be quite interesting for you. So my name is Murat Mayan, and I'm the CEO and the founder of Innovation Technologies. And in the next 15 minutes, we will talk about carbon to value approach. It's less maybe common. We are not in the field of sequestrating things under the geological storage, but actually creating profitable materials, and by that, enabling actually support a low carbon hydrogen. So we'll not talk about colors because, you know, in Europe, the colors are a little bit not used anymore. Previously, they were green and blue and gray, of course. But let's talk about the low carbon hydrogen in a reasonable price point that we can actually support. So if we take out all the labels of climate, it's very important to figure it out what is the need. And the need is to help to transform how to abate big sectors, energy sectors, to become more circular, more environmental, and more profitable. This is kind of the major issue. And by doing that, we need to, first of all, I think, put reasonable and logical goals. Some of our problems, and maybe a disappointment that I felt months ago in Hamburg in the hydrogen event, in carbon capture and hydrogen event, was mainly because our goals that we are putting in front of us are very short, and we're not achieving it. And in the reality, this transformation will take much more time. We need to understand it. So, innovation, taking carbon to value approach, we're doing point source, capturing all the way toward the material, and we're using actually two problems as the feedstocks. So what are the problems that we're actually facing? On one hand, we're taking point source emissions, but on the other hand, we're also enabling by capturing and mineralize it by using another waste that's called phosphogypsum or waste gypsum that comes and build up in millions or millions, hundreds of million tons a year, create profitable materials. And by that, enabling to solve another problem of the price. To mature the hydrogen market, to create more clients for the hydrogen, we need to create smaller steps of price that those industrial players will adopt it. And the big problem with it today, unfortunately, we didn't yet overcome the price point in the green one, in the water-based. So we're aiming to support the hydrogen that produced today in 100 million ton, the gray one, okay, to make it low carbon. 1 ton of CO2 that we'll capture from SMR, straight away from the emissions of standard SMR, will be processed with a 3 ton of the phosphogypsum. We can use phosphogypsum, but we can use also FGD. It's a gypsum that piled up from the coal power plants. Both of those materials are very accessible all around the world. And we can use also natural mined. Of course, the two first that we're using and creating calcium carbonate, we're avoiding the need of additional material mining. We're creating, on the other end of the process, 2 tons of sulfuric acid, or we can go before on ammonium sulfate as a fertilizer. I'm sure you know that sulfuric acid is one of the most usable materials today in the world. As we're going to energy storage, we need to actually process more metal. For that, we need to use more sulfuric acid. On the other hand, the nature storing CO2 in calcium carbonate. This is the natural way that in the world CO2 is stored. And in this case, we don't need to go and look for any geological storage. We're creating calcium carbonate, limestone, and the quality of the calcium carbonate will be highly depend on what type of gypsum that we're using. All of that done with very low energy consumption. So internally, our life cycle analysis, it's 300 kilos of CO2 on each 1,000 ton that we are capturing. 400 kilowatt hour for 1 ton of CO2 in the capturing. But if you're looking on the avoidance element as well, we're avoiding around 800 kilos of CO2 on top of that from not mining or saving the need of mining and additional calcium carbonate. So yeah, we are happy to have free revenue streams, but we're not relying on carbon credits as a major one or the only one. In some sense, it's kind of the cherry on the pie. I will show you a short video that actually focuses on Europe.
Tons of phosphogypsum have accumulated, a legacy waste from decades of phosphate fertilizer production. From massive stacks in Poland, Greece, Bulgaria, Serbia, and Kosovo, to medium-sized sites in Belgium, Portugal, Finland, and the Netherlands. This waste represents both a burden and an untapped opportunity. In Huelva, Spain, more than 100 million tons of PG stretch across 1,000 hectares. What if this waste could do more than sit idle? With Innovation's mineralization platform, Europe's phosphogypsum becomes a launchpad for carbon-negative transformation. Together, these stockpiles can permanently remove up to 700 million tons of CO2, produce 1.4 billion tons of low-carbon calcium carbonate, and enable 1.3 billion tons of low-carbon sulfuric acid, reducing emissions and eliminating the need for new raw material extraction. This is not just remediation. It's a profitable, climate-positive solution, powering Europe's Green Deal, the CBAM, and a continental blue hydrogen valley. Aerovation, turning CO2 and industrial waste into tomorrow's resources. Now in 2050, our environment is cleaner, industries are thriving, and the future is brighter, proving that visionary decisions drive meaningful change.
So the markets, I think, are quite clear. And I can tell you the technology is one that maturing this technology for the last year, 8 years, and kind of scaling it now. And maybe in the last year, we can call ourselves differently, because until now we were a startup, and now we're kind of shifting toward the scale-up stage. Technology is important, but frankly, it's not enough. Okay, and until you will not take one step back from and stop becoming in love in your technology that you matured and start to look on value chain, you will not able to create the business. So maturing technology important, but you need to go and actually analyze it more and more from the value chain perspective. So on our hand, creating these clusters, those local clusters that I will show in a second, it's a key success for scaling up well those mega projects, those mega future projects. So the markets, everybody needs carbon capture, but this is not the issue. The issue where it can be deployed. Okay, let's talk a little bit before on the alternatives, because our choice will be always a front of alternatives. And I think that, again, my experience engaging with the real industrial players, manufacturers, hard to abate sectors, steel, cement, that my friend here involved as well, hydrogen, it's hell, okay? It's long process, it's engineers, it's lawyers, it's very slow movers in many fields, and really try to change them, it's a big mission. And because of that, I think some sectors kind of came to life from my perspective. And one of them was, of course, the direct air capturing. So we need many, many tools. There's not going to be silver bullet, one solution. But you can split this map to two sectors. You have carbon to credit approach that's saying, let's create credits, and someone will be penalized, and then he will have to buy the credits. It's we decided not to go to that path, not to adopt such approach. We're happy that the credits will go up. It's additional revenue stream of us, but this is not the major. In Korea today, the credits are $6, okay? In the US, there are no incentives in the next 3 years. So to build a business on that, I think it's not really reasonable. We went to approach of carbon to material on the bottom. So of course, amine base, it's known. Amine, potassium, all the looping, chemical looping processes are known practices that in some sense they're kind of a sponge, okay? Chemical sponge that capturing, and then by heating it or by pressuring it, you're releasing it, so you have to release it to somewhere. Utilization in methanol, ethanol, of course, all of that highly important. In this case, we're creating material with value. We're not seeing the carbon as a problem. We're seeing the carbon as a material that have to be utilized. Now, we are doing point source, so we don't need these pipelines or future pipelines that are, for example, planned in Europe. But with those plans in Europe of infrastructure of downstreaming CO2, they coming with additional requests of bringing the CO2 before it's going to be downstreamed to the level of the food grade. 99.99, no SOx, no NOx. Just this element costs you hundreds of millions of euros in each point to purify the emission to that level. Okay, so in our case, no need to purify it. It's mineralization all the way, and we don't need to go to reservoirs and look for reservoirs under in the sea. Of course, sequestration, it's a not new method. Oil and gas doing sequestration for the last 60 years or more, increasing the pressure of the reservoir. But I think we're offering a profitable way to do things. So this is a hydrogen valley that now initiated in Israel. And moving forward now, so I kind of made this picture in front of my eyes 3 years ago, and I'm happy to announce that it's already under full contracts, and now starting to be also pilot kind of supported with the government. What we have ICL, fertilizer company that piling 3 million tons of waste every year. 60 million already piled. They piling 3 every year. And 3, it's only 1% of what piled every year around the globe. Crazy amount of environmental waste. NewMed Energy are supplying natural gas to Egypt, Jordan, Cyprus, and Israel. And they like to deploy or play in the hydrogen field, have additional portfolio product. But of course, they would like to rely on their methane. And the way to do it is capturing the CO2 from the process. So here you can see a site that will generate around $600 million when we're aiming on the clean hydrogen in the $4, or let's say we can even aim much lower, because you have here additional 200 million that comes from other material that can, in some sense, play. You can have the flexibility and not relying all the cost just on the hydrogen production. We are scaling now, so the Israeli project is now moving in this coming year. It's finished the permits stages. Will be started to construction. Again, not straight away from the 100,000 ton or 1 million ton of CO2, but we're starting with semi-commercial site of 3,000 square meters. We're maturing now, and in Korea we already signed a framework agreement, very similar, that in going and finish the pre-feasibility study, moving towards full feasibility study in 26, and planning with a purpose to launch it in 27. Same happening actually in Belgium. And of course, we was also selected by NEDO in Japan. And there is a very nice consortium that was built in Japan with several entities. And NEDO was accepted us. We kind of got the grant for the first step, and now we're moving for finish the methodology writing. Thank you very much for your listening and for your time, and I'm happy to answer any question.
네, 감사합니다. 이스라엘 기업 에어로베이션 마야 CEO님의 발표 함께 하셨습니다. 네, 이어지는 발표는요, 신재생 에너지로 생산한 그린 수소를 공급하는 호주 수소 기업입니다. 일렉시드인데요. 일렉시드의 로버트 사운더스 매니징 디렉터님께서 발표하시겠습니다. 큰 박수 부탁드립니다.
Good afternoon, everybody. Good day, as they say in Australia. I'm Robert Saunders, the Managing Director of Alexseed, based in Brisbane, and it's a pleasure to be here, and thank you to the organisers for the opportunity to speak with you this afternoon. A little bit about Alexseed. We are engineering consultancy in clean tech and also developers using Korean technology and investment for renewable projects and assets across Australia, with an office in Seoul and Brisbane, connecting the dots and acting as a bridge between our respective nations. So it's a very interesting time for Korea and Australia to work together, if you like, on three key pillars. One is obviously investment in technology. Korea is investing in Australia in the clean sector. Also is a huge manufacturer of clean technology, which we've seen today at the conference. And Australia needs both of those for its renewable appetite and assets. Secondly is decarbonisation. Australia needs to decarbonise and needs support from Korea to facilitate that. And Korea imports LNG from Australia. Australia is the #1 exporter of LNG to Korea. And they want to replace that with clean gases such as ammonia and green hydrogen. And of course, recently, the Korean government announced the stoppage of coal in the next few years. So that adds more emphasis upon that. And the third is sharing knowledge and research, some of which is going on here at this conference, but we need to learn and collaborate more than ever. And Korea and Australia is as politically aligned as it's ever been and is well positioned to facilitate that third pillar. A little bit of context before I go into the project about why we're here. So climate change, it's in our face every day of the week. You can't avoid it. Obviously, organisations, corporate companies, governments positioning themselves with ESG policies, aligning with United Nations Sustainable Goals, and they need to facilitate those to decarbonise their assets. And the young people, the next generation, our generation, there's serious concern. I live in Australia, bushfires, flooding, it's in the news every day. So we really need to move forward at a faster pace. And the science, some of the political leaders around the world, which will be nameless, see the climate change as a non-event. But you cannot ignore the science. You cannot. Oceans, across the land, fires, it's as I said, it's prevalent. In Australia, some of our politicians have pulled back from their commitments, which is disappointing. So we need to push to align and keep those moving forward for the well-being of our planet. And this is generated by humankind, by us. If you consider the Industrial Revolution, the first coal-fired power plant was in 1882 in London, Thomas Edison, and the first gas, I believe, in the mid-40s in the US. But if you look at the carbon emissions, 38 billion tonnes per year last year, up 0.8%. It's all occurred since the Industrial Revolution, and the science supports that through trapped gas and monitoring. So it's happened in the last 200 years. It's quite an alarming statistic. However, there is a silver lining, and this is some context ahead of our project that I'll talk to you about. A little bit about Australia, where I come from. Some of my colleagues are with me today, including our CAO, who's travelled to be here, so it's good to see them. But Australia, it's a very large nation. We have an abundance of solar, wind, and land. Indeed, we are well positioned to be what I call the food bowl of green energy. Well positioned. We also have transferable skills from our LNG industry, very advanced skills which can step into this arena to support being that superpower. Of the 7 forms of renewable energy, we have 6 abundant happening today. We have active projects across our country, across 6 of those, and arguably the 7th as well. And then Korea. Korea is an envious nation, an industrial nation that the world looks upon as one of the leaders in clean technology, all forms of technology, AI, automation, electronics. Very enviable. However, this comes at the need for energy. Your energy doubled in 20 years and will continue to go up to higher levels. So to decarbonize, you need to find other forms of energy to position yourself to keep your economy moving as it grows. And then there's hydrogen. Huge amounts of demand for hydrogen driven by the government here, for power stations, for mobility, manufacturing, but it's got to come from somewhere. In Australia and states like South Australia, who are very supportive in this arena, are well positioned to facilitate that. So Elexceed has a master plan, and I'll talk a little bit about that ahead of our project in the cement industry. First of all, we made a little bit of a mistake. Australia has somewhat gone for large-scale export projects in the last 2 or 3 years. No excuses for that. We're well positioned because we export LNG and other commodities. We're an export nation of commodities. But a lot of them are now collapsing. They're all failing because of the economic viability, the technology, and also the logistics. It just wasn't ready. But what we've done, we've forgotten about ourselves. I've been here a week. I come here every month to Korea. So this is my 9th visit to Seoul this year. And I see hydrogen cars, hydrogen buses, fuel cells on every visit. In Australia, I don't see any. We've forgotten about ourselves. So we have a master plan, if you wish, to forget about hydrogen 1.0, which is a failed attempt at immediate export, and go back to the beginning to local applications, which I call hydrogen 2.0, and then have baby steps up to that scale of export in the future when we can bring down costs, increase technology, support logistics, make the right decisions, and then have another attempt in a few years' time. So this is our project. This is a good example of a local Australian project in that space, starting with Korean and government support and technology and investment. Project Helios. Project Helios is in the cement industry. It's a joint venture between, or MOU, between the South Australian government, who are in this room today, ourselves, Alexeed, a cement company in South Australia, well-respected organisation called Hallett, and also Korea Hydro-Nuclear Power, Korea's largest power company. This was signed a few years ago, and the project is about 3 years old, and now progressing into detailed engineering and costs. And it's in the cement industry. The cement industry represents 8% of global emissions. Every year, more cement is used. We're standing on it, sitting on it, and wherever you look, it's around us. It's the second most used commodity after water. And every year, cement use is going up, 20% growth expectation in the next 20 odd years. So we have to decarbonise it in some capacity to meet our objectives. And then there's coal. Around the world, coal-fired power stations are being closed. Korea's just committed to reducing their coal only last week. In Australia, the graph on the left here represents the decline of coal and the closure of coal-fired power stations across our various states. Some jurisdictions are prolonging that, but in the main, they're closing, and some already have, which I'll talk about shortly. But of course, from coal, the byproduct is fly ash. And the fly ash is then sat there forever and a day in huge dams mixed with water, doing nothing. However, it can be used for cement production as a feedstock. In this drawing here, or this photograph here from our project, on the left-hand side there, you'll see a sandy colour area that's 8 metres deep, 40-year supply, and a few kilometres long of fly ash. And that fly ash from a redundant power station in this town or city called Port Augusta, 3 hours north of Adelaide in South Australia, a wonderful part of the world, is positioned adjacent to a cement facility that's being built at the moment. It's half constructed. And that will be used as a feedstock for that cement production. Our Energy Minister, the Honourable Chris Bowen, in the right-hand corner there, visited the site last year in support of the project. And it's quite globally unique in what it's trying to achieve, and a good example of using redundant coal-fired power stations for secondary use, which is quite ironic. This is a photograph we took when we were on site a couple of years ago of the fly ash which we dug up. Now that fly ash has moisture mixed with water, and it has to be dried. It varies, but typically it's around 20 to 25%. But for the construction, the production period process, it has to get down to 0.5%. So it has to be dried through a drying oven process. And typically that's done by fossil fuel, such as natural gas or liquid propane gas or some other means. But what we're doing is we're drying it through green hydrogen. Adjacent to the site, we're constructing a solar farm. We're having a green power purchase agreement for wind, which is in abundance in South Australia. And we're decarbonising the process by drying that fly ash through green hydrogen in lieu of LPG through a burner as part of the oven process. As part of the master plan, that cement, once it's produced, will then be used in electric or hydrogen fleet in mobility as a second stage to take that cement into our mining sector and our critical minerals sector, just north of the site, which is now exporting commodities such as copper around the world, including here in Korea. So the site layout, as I mentioned, the cement facility is sort of half constructed. It has ovens and processes with a company called Hallet, that's their domain. And we're producing that solar and hydrogen facility. We're using Korean technology and Australian and British technology as an alliance to support that. And we're piping that hydrogen to those burners. We're starting off with a blend, primarily due to risk. This is in remote Australia. The closest service engineer for the burner could live in Munich, so we have to mitigate risk in the first instance. But the intention is to ramp up the blend to 100%. And the LPG provision in the area is being shut off by Santos from next year, so that could be fast-tracked to 100% quicker than we anticipated due to the supply of the fossil fuel gas. I mentioned critical minerals. South Australia, Australia generally, is another food bowl of critical minerals. Minerals that are used in battery technology, in cars, all sorts of things that we're crying out for. That's why there's a lot of interest around the world from world leaders to get their hands on it. This cement is used to backfill, if you wish, the mines that's extracting those commodities. So we're making green cement. That cement's going into the mining sector. Those commodities are then going up to countries like Korea that then produces technology such as batteries, which then gets exported globally. So it's the circular economy and supply chain piece to this project as well. A few renditions of the project, just to give you a flavour of what it looked like, although it is work in process as we progress the engineering. The solar farm in the background, the hydrogen plant in the foreground, from a bird's eye view. Once the project's completed, as I mentioned, we have a second stage, which is decarbonisation of the other opportunities in the area. Mobility is a key one. Port Augusta is what's called the crossroads of Australia. You have to travel through it from Perth to Sydney or from Adelaide to Darwin. So it's heavily used by heavy haulage and people on their round Australia trips. So there's a huge opportunity in that space, as well as other industries in the area. So there's a second step for that hydrogen use, which we're working on beyond the hydrogen for the cement industry. And of course, once that's finished, we have ambitions to scale up. And the LEXEED has been involved with the Korean Advanced Institute of Science and Technology on a study to look at the logistics. It took us 4 years. We've got a Korean government grant. Professor Chang from KITEX is here today. It's a pleasure to see him once again. And we work with KOGAS to look at the logistics, because that's a missing piece. So concurrent with doing this project at a local level, we're also working on the logistics and export opportunity to scale up, to use our methods, and if you like, go back to what I said earlier, hydrogen 1.0, and have another attempt at export with further knowledge and understanding. And that's just a little picture using that clean energy, producing green hydrogen and exporting it up to countries like Korea, where we are today. In South Australia, where the project's located, is very well positioned as a partner to support that. It has deep sea ports, expertise, political will to be that key export hub, if you wish, for this project. So our master plan is to start with local projects, such as the cement industry, 8% of global emissions, and over the next decade, have another go at export with further knowledge and technology and investment. Thank you.
네, 호주의 사례를 구체적으로 설명해 주셨는데요. 다시 한번 큰 박수 부탁드리겠습니다. 네, 다음은 수소 연료 전지 기술 분야의 세계적인 선도 기업이죠. 스웨덴 캐테이터 AB의 사례를 만나보도록 하겠습니다. 발표는 아민 메흐디프르 비즈니스 개발 이사께서 해 주시겠는데요. 박수로 맞이해 주시기 바라겠습니다.
Thank you. Yeah, good afternoon, everybody, and thanks for coming to listening to this presentation about our company and our very unique heat exchanger for fuel processing. So I will start with a very brief history of the Katator and our company. Katator was born about 35 years ago, more than 3 decades ago, in south of Sweden by 2 researchers within the catalyst technology. we have developed a quite unique catalytic coating technology, which we call Catalyte technology, and I will explain to you a little bit later. And that unique technology has enabled us to come up with very unique reactor design for the hydrogen ecosystem. So by that, we have served several customers within the electrolyzer and fuel cell application, syngas and e-fuel production, and also fuel reforming applications. As I mentioned to you, the base of all our solutions are our very unique catalytic coating technology, Catalyte technology, and by that we could have deliver projects in the form of contract development service, meaning that we get the information from the customer, we design everything for them, we coat the catalyst, and then we build them hardware and reactor, and then we send it to them as the hardware. And in order to be able to give better service and cover a wider range of applications, we have come up with 4 different technology platforms based on different applications, covering a broad range of applications. For example, here you can see catalytic scene reactors, which means the reactors for fuel synthesis. Then we have reformers for fuel reforming, burners in emission control applications, and also the whole system for e-fuel processing. So if I start with the catalyte coating, that's a quite unique and patented technology, including 3 different stages. First of all, we get the metal surface, we roughen up the surface, and by that we are increasing the surface area while keeping all the pores and holes in it in order to reduce the pressure drop. In the second stage, we spray the ceramic layer, and at the end, we spray the active catalyst phase. So by that, we can go down in the reactor size up to 80% sometimes. We can enhance the efficiency because of all the thermal characteristics, and we have also done several tests to see if the addition of the catalyst to the metal surface is strong enough or not, and the performance of the catalyst is affected or not. And here you can see some of the tests that we have done. For example, in this case, we have coated the catalyst on a plate of a plate heat exchanger, and we exposed this plate to more than 1,000 cycles of heat exposure, and at the end we saw less than 1% weight loss of the catalyst. So addition is not a problem at all. And we did a similar test to compare our catalyst with the commercial metal honeycomb conventional catalyst solution in the market, and we saw that under the same test for heating at 1,000 degrees and then followed by ultrasonic treatment, the commercial metal honeycomb showed almost 6 times more weight loss compared to our coating technology. And about the catalyst lifetime, we have also tested it at a customer, and we saw that even after 10,000 hours of operation, most of the performance of the catalyst stayed same as the very first day. So we haven't seen any degradation after that time. And we have customers in global customers that have been running with this catalyst for more than 30,000 hours sometimes. So if I go a little bit deeper into application of this coating technology, as I mentioned to you, this flexibility gives us the possibility to come up with several forms of designs and applications. And here you can see that we have developed a quite unique heat exchanger technology that we call CATAREX, which is a catalyzed heat exchanger. And it can be applied, for example, for selective oxidation, for methanation, methanol reforming, any fuel reforming that you can imagine. And that's basically a catalyzed heat exchanger. In this specific case, you have the possibility to catalyze the 2 sides of the heat exchanger with 2 different catalysts to achieve 2 different reactions. So we are using integration of an exothermic reaction and endothermic reaction in one reactor. And this is a sample that we have sent to some of our customers. And if I want to give you a concrete example, this is one of the customers that we have developed this technology to them. In this specific case, these guys are cracking ammonia, and then the hydrogen, the produced hydrogen, would go to a solid oxide fuel cell. So we get the anode waste gas from the fuel cell, we send it to one side of the heat exchanger where we have catalyzed with oxidation catalyst, and then at the end we get emission-free off gases and some heat which has been generated by this reaction. On the other side, we send the stream of ammoniac inside. We have catalyzed the other side of the reactor with reforming catalyst, and then the heat generated on the other side could go to this side because that's an endothermic reaction, and we get the hydrogen outside. So instead of an anode waste gas burner, a possible heat exchanger in the process, and also a reformer, we developed this KINTEX technology which can do all three jobs in one single vessel. And we are able to design both shell and plate or shell and tube or tubular designs depending on the process conditions. For example, in this case, shell and tube is the most efficient one, but it is for the low pressure applications. But if we want to go to a higher pressure, for example, 16 bar, 30 bar, 20 bar, we can come up with other robust designs, which is tubular design in this case. And this could also be used for electrolyzer application, not the same concept, but the catalyte coating concept. We could use these wire meshes and we could catalyze that with the oxidation catalyst, and then we could apply that into the oxidation reactor. And here come some examples of the application. We have developed this device or this reactor which we call catalyte burner. It comes into different sizes and different applications. If I start with the, for example, electrolyzer application, we have delivered these units to so many electrolyzer manufacturers globally that they wanted to treat their hydrogen vent gas, especially during the transient condition when the hydrogen concentration is too high. There are still, unfortunately, no environmental regulation for that, but when we talk with the European customers, most of them are seeing some regulations being applied soon. So it's a sort of a, action that they want to take it in advance. And so this customer is treating the hydrogen vent gas or hydrogen emission during the upstart and transient condition. And also, these guys are doing a co-electrolyzer of the carbon dioxide as well. And in that case, it's not only the hydrogen emission, it's also carbon monoxide emission that needs to be taken care of. And with our burner solution, we can take care of that as well. This is one of our very few off-the-shelf products. We have already developed the design, everything is ready, and we have different sizes for different flow rates, and the operating range of these devices are quite broad, and they can take care of many different emissions if necessary. And then we have another concept of the burner, which is a smaller one for anode off-gas burner for the fuel cell. The logic behind it, this device is like these reactors, so we have a catalyzed mesh for this specific application, and then we can apply this for this reformer in order to take care of the anode off gases coming out of the fuel cells if necessary. And this is one of the examples that, for example, for this specific customer could be replaced by the KINTEX here. Yeah, that was my presentation. I hope you enjoyed. I intentionally kept it quite short in order to be able to answer any question if there is any. So yeah, you're welcome to ask your questions if there is any. Thank you.
네, 감사합니다. KT의 제품들에 대한 소개도 함께 만나봤습니다. 네, 다음으로요. 네덜란드 수소기업입니다. 브롱호스트의 사례를 만나보도록 하겠는데요. 네, 박수로 맞이해 주시기 바라겠습니다.
Thank you very much for introducing me. My presentation is about precision hydrogen flow measurement in solid oxide fuel cell and electrolyzer cell applications. Broncos is a specialist in flow measurement, and I'd like to focus on the flow measurements. My name is Peter Brouwer. I'm already a long time at Bronkhorst and responsible for product management and market development. I have a clear vision on that we should decarbonize, and also that I investigated a lot of energy in the hydrogen market. So Bronkhorst is the low flow specialist. We focus on low flow. We are not focusing on the high flow rates for the big projects that we heard of before. We are more focusing on R&D projects, on test systems, on all kinds of production systems for these systems. And we are a pioneer. This means 20% of our people are working in R&D. We are the creator. The creator, that means that we invent a lot of new things. We have a lot of patents, and our patent portfolio is still increasing. And we are looking always for collaboration. Collaboration in the style of collaboration, long-term relationships with our customers, long-term relationships with our people, and also our suppliers. So we are active in many markets. We have widespread instruments. Our instruments are widespread used in all these different markets, but we said we should have focus on the renewable energy market. If we look to our company, we have 40 years of experience. The company was founded in 1981. We have 800 employees worldwide, and we have a good network that we have 24 hours a day technical support and over 1 million instruments in the field. So where are we located? We are our headquarters is in the Netherlands. All our products are produced there. And we have now also in North America and Asia a small production units. We are expanding also in that way. And for example, here in Korea, we have our own sales and service office. So let's dive into the solid oxide technology. So maybe you're not familiar with it. If we look to solid oxide, what is it? It is a technology. It's a technology in development. If we look to electrolysis plants or fuel cells, nowadays most of them are alkaline or PEM, proton exchange membrane systems. And the new technology where everyone is focusing on is solid oxide. It is a technology to build electrolyzers or fuel cells, and it has a solid oxide electrolyte which is activated at very high temperatures. So it's around 700 to 850 degrees centigrade. And why is there so much focus on this technology? It's because it's highly efficient. It has an efficiency up to 85%, and if you compare that with alkaline or PEM, it's both around 50%. So it's much more efficient than the technologies that we are using nowadays. A second advantage is that you can produce e-fuels if you do a CO2 electrolysis and water electrolysis together in one system. Then you can create directly a syngas, a mixture of H2 and CO, for e-fuel production. And that is something that is very interesting because it's already high temperature technology. You need this high temperature also if you want to produce e-fuels. And when you make a fuel cell with this technology, it's not only capable of transforming hydrogen into electricity, but also other gases or liquids like ammonia, natural gas, or methanol. So you have flexibility in your system that you can switch from hydrogen to methane or use a mixture of it, etc. So what are the research topics in solid oxide technology? I think the first research topic is thermal management. If you have a system for 700 degrees, you heat it up, you cool it down, you heat it up, you cool it down. We heard it from the previous speaker as well. Then you should have focus on that your system is stable and that that the thermal mechanical stress is under control. Stability is the next topic where there is research on. So material degradation, what kind of new materials can we use, what catalysts can be applied, etc., is part of the research. And last but not least, Faradaic efficiency is important. That means that every electron that you use is used to create the gas that you need, for example, hydrogen. And if that's not in balance, then you know that there is some leakage or some other effect in your system. So Faraday efficiency is important to measure. And well, I'll dive further into that. So this is a very technical slide, maybe much too technical for the audience here. But it is an example of a balance of plant of a solid oxide electrolysis system, and I will guide you through. In the middle we see here the solid oxide cell, and at the inlet there is electrical power. The electrical power is used to split the water into hydrogen and oxygen. Then we have a water inlet, and from the water inlet we need to produce steam. Because it's a high temperature system, you need water in steam phase, in gas phase. So it's preheated, it's evaporized, it's heated more, and then brought into the cell. Then there is an air inlet, and the air inlet pushes the oxygen out of the system, which is cooled down and vented into the air. The oxygen is a byproduct. In most cases, it is not used. And the hydrogen output needs to be cooled down as well. So again, through all the heat exchangers going to the outlet of the system. So what is the role of Bronkhorst in these systems? We are the supplier of all kinds of instrumentation for your research, for your test systems, etc. For example, the air inlet can be controlled with a mass flow controller. And the outlet of the system, the pressure of the system can be controlled with pressure controllers. And the water inlet can be measured with a Coriolis mass flow meter. And we also supply the controlled evaporator mixer systems, which can be used to create the steam which is necessary for those systems. And last but not least, you need to measure the hydrogen at the outlet of the system to check the performance of your system. Let's dive into the mass flow controller. Because this mass flow controller, as I mentioned before, it's a kind of counting of the molecules that you made, and you compare that with the electrons that was your input of your system. So if you create one hydrogen molecule, you needed 2 electrons to create it. And that is what is meant by Faraday efficiency. So Faraday efficiency is 100% if all your electrons are used to create hydrogen. And that's the target. It is not the power efficiency, it is the Faradaic efficiency. Of course you have power losses, but every electron needs to be used to create hydrogen. And when we dive deeper into that, then you can understand that it's important that this measurement is very accurate. You're looking for losses like 1 or 2% in your system. And when your meter already has that accuracy, then you don't know if it's the inaccuracy of the instrument compared to the effect where you're looking for. And measuring that flow rate is not that easy, because the hydrogen always contains a little bit of water. Although you use a separator and you condensate the water, there's still a little bit in it. And most of the time the gas temperature is not yet ambient, but around 30, 40, 50 degrees. And there will be gradients, temperature gradients over such instruments. So why should you use a thermal instrument there if you have so many thermal effects? And the answer is there are not many other choices that you have. The choices that you have is, for example, Coriolis flow meter, but Coriolis has a lot of pressure drop. So when you look into the market what's available, then the thermal gas measurement is still the best to use. But as I mentioned, there are challenges. But Bronkhorst has some solutions for that. For example, you need to have a good starting point. So you need to start with a good, accurate flow meter, and we have some tips to prevent temperature gradients, and that you should dry the gas as much as possible, and check afterwards if your instrument is really correct. So calibrate the instrument, convert it for a mixture if you have a mixture with gas and water, and create a stable environment. So our solutions. I thought I already had this slide. So the first thing you can do is that you choose for a real gas calibration, that you have an instrument that's already calibrated on the gas hydrogen and not on something else. And that's possible. We have solutions up to 200 cubes per hour of hydrogen. We made our own calibration system with a closed loop recirculation of the gas, that we don't waste the hydrogen gas but reuse it in a circulated system. And with this system you have the best possible accuracy as the start of your measurement. And then next to it we have a nice thing that we call real-time gas conversion. If you add, for example, a humidity sensor to your system, the output of the humidity sensor can be used directly inside our instrument to know what is the mixture of water and hydrogen, and then the flow meter calculates what is the amount of hydrogen and what is the amount of water of the mixture. And we have that in our line L-Flow Prestige and L-Flow Compact. Then I'd like to make some product announcements, which are also important for the hydrogen industry. The first one is a new generation of our X-Flow series. The X-Flow series is an instrument series for Zone 1 applications. So when you have hazardous environments, we have Zone 1 solutions already available. But the new thing of this is that it's a more compact design, because it's an integrated controller which you can directly connect to your own barriers, in which you can choose your own. And there is no need for expensive cables or control units anymore. So it's a new digital flow controller which can directly be hooked up in the way you want it yourself. And the other product that I want to have in the picture is the L-Flow inflow upgrade, the inflow upgrade. The inflow upgrade is, and we already have the inflow line, but it's upgraded to higher flow rates, to 1,000 cubes per hour as an integrated controller. And it is now faster and less sensitive to all kind of outer effects. So that's coming to my conclusion. So the conclusion is Bronkhorst are the low flow specialists. We are focusing on energy transition. Solid oxide technology is an upcoming new technology. And developments require accurate instrumentation, and flow control is one of them. Flow control is still challenging, but we offer solutions in real gas calibration, real-time conversion if you have a mixture, and we develop new instruments for demanding hydrogen applications. So thank you very much for your attention.
네, 감사합니다. 네, 지금까지 정밀 유량 제어 솔루션 분야에서 세계적인 기술을 갖춘 브롱호스트의 소개 함께 하셨습니다. 네, 다음은요. 알파 라발에서 준비해 주셨습니다. 수소 생산, 유통, 저장, 운송 등 수소 산업 전반에서 맞춤형 솔루션을 제공하는 글로벌 기업인데요. 신명수 세일즈 매니저님께서 발표해 주시겠습니다. 네, 큰 박수로 맞이해 주시기 바라겠습니다.
안녕하세요. 저는 한국 알파라발에서 산업용 열교환기를 담당하고 있는 신명수라고 합니다. 오늘 발표드릴 자료는 알파라발 시각에서 바라본 수소 솔루션의 최적화 방안에 대해서 설명드리도록 하겠습니다.
마이크를 이용해 주셔야지.
네.
네, 우리 동시통역사분들께서 동시통역을 하실 수 있습니다.
네. 먼저 국제에너지기구 IEA에서 발표한 2050년까지 시간 경과에 따른 탄소 배출량 추세선입니다. 빨간색 선은 우리가 계속해서 산업을 발전시켰는데 아무것도 하지 않았을 경우에 이산화탄소 배출량이고요. 다른 선들을 이제 확인을 해보시면은 에너지 효율성 향상, 재생에너지, 연료 전환 등을 적용을 하면은 탄소 배출량을 획기적으로 절감할 수 있을 것으로 기대되고요. 이 모든 최적의 시나리오가 적용이 된다고 하면은 산업이 계속해서 발전함에도 불구하고 미래에 배출된 탄소를 약 4분의 1까지 절감할 수 있음을 보여주고 있습니다. 알파라발의 목표는 고객, 사람, 그리고 지구를 위한 지속 가능성을 가속화하는 것이고 두 가지 큰 방법을 제시하고 있습니다. 첫 번째는 에너지 효율 증가와 자원 회수를 통한 기존 산업의 지속 가능성을 높이는 것입니다. 그리고 두 번째는 진보된 기술과 솔루션으로 청정 에너지와 순환 경제로의 전환을 가속화하는 것입니다. 알파라발은 에너지 효율성, 순환 경제, 청정 에너지라는 세 가지 주요 지속 가능한 분야 중심 분야를 바탕으로 고객과 지속 가능한 파트너십을 추진하고 있습니다. 이 중에서 알파라발은 특히 집중할 7개의 청정 에너지 기술 분야를 선정하여 역량을 집중하고 있는데요. 오늘은 수소 산업에 대해서 집중적으로 설명드리겠지만 수소 외에 다른 산업에서도 알파라발의 에너지 효율 아이디어가 있으니 관심 있는 분들의 많은 연락을 기다리도록 하겠습니다. 알파라발은 이제 계속해서 에너지 효율을 강조하고 있는데요. 에너지 효율화를 통해 생산 비용을 획기적으로 절감할 수 있음을 다시 한번 강조드리고요. 그렇다면 가장 좋은 에너지 효율화는 어떤 것일까요? 첫 번째로 생각할 수 있는 것은 불필요한 에너지 사용을 줄이는 것입니다. 그리고 두 번째로 좋은 방법은 에너지를 재사용하는 것인데요. 알파라발은 ABB와 함께 EEM이라고 하는 에너지 효율화 운동을 진행을 하고 있는데요. 600명 이상의 회원이 참여하고 있고 알파라발의 에너지 사업부 사장이신 토머스 밀러 씨는 EEM의 집행위원회에서 활동을 활발히 하고 계십니다. 하나 재밌는 통계 보고 지나갈까요? 전 세계에 설치되어 있는 열교환기들이 회수하고 있는 에너지는 약 50기가와트로 추정이 되고 있고 약 25메가톤의 CO2를 줄인다고 보고되어 있습니다. 이제 50기가와트라는 숫자는 어떤 숫자인지 좀 살펴보면은 약 1000만 가구가 난방에 사용하는 에너지와 동일한 숫자이며 파리에서 사용하고 있는 에너지와도 동일하다고 합니다. 이를 통해서 우리는 에너지 회수가 우리에게 큰 경제적, 환경적 혜택을 줄 수 있음을 간접적으로 좀 확인할 수 있겠습니다. 앞서 말씀드린 것 같이 알파라발은 파트너십을 통해 진정한 혁신이 이루어진다고 믿고 있는데요. 이번 박람회에 앞서 진행된 하이드로 컨실에서도 알파라발은 회원사로 역할을 다하고 있습니다. 하이드로 컨실 외에도 알파라발은 클린 하이드로젠 파트너십, 에너지 이피션스 무브먼트를 통해 하이드로젠 유럽의 프로젝트 회원으로 역할을 하고 있습니다. 탄소 중립은 세계적인 관심사인데요. 현재 약 90여 개국이 탄소 중립 목표를 설정해 주셨고요. 50개국 이상이 수소 전략을 도입하고 계십니다. IEA에 따르면 2050년까지 전 세계 에너지 수요의 최대 약 20%를 수소 또는 그 파생물이 충당할 것이라고 예측하고 있습니다. 이제 조금 있으면 서론이 끝나는데요. 지난 몇 년간 수소 에너지에 대한 관심이 이제 폭발적으로 증가를 했는데 역시나 이제 수소가 관심이 많죠. 근데 이제 알파라발이 가진 소형화된 고효율의 장비를 통해서 수소 생산, 유통, 저장 및 최종 산유 분야에 모두의 광범위한 열 전달 기술을 제공할 수 있음을 강조드립니다. 이 그림은 그 재생 에너지로부터 전기와 수소를 생산하고 그리고 파생 상품으로 전환, 즉 수소 산업 가치사슬 전반을 알파라발 시각에서 도식화한 것입니다. 전기분해, 담수 생산, 연료 정지, 충전소에서의 냉각, 그리고 메탄올 및 암모니아 개질 얘기까지 수소 가치사슬 전반에 알파라발의 공정 최신화 아이디어가 있으니 함께 살펴보도록 하겠습니다. 첫 번째는 수소 생산에 대한 내용입니다. 이 그림 역시 이제 알파라발 시각에서 바라본 수소 생산과 활용 과정인데요. 거칠게 요약을 해보면 저 상단에 있는 풍력과 태양광 발전을 통해 생산된 전기는 전해조에서 물을 전기 분해합니다. 그리고 이 과정에서 발생된 열에너지를 회수해서 담수도 생산을 하고 지역 난방이나 공장의 열원으로 사용한다는 개념입니다. 즉 전해 공장에서 벌어지는 열연을 회수하고 고효율의 열경기를 적용해서 에너지 절감과 경제적 효용을 높이고자 하는 아이디어입니다. 먼저 이제 전해조에 대해서 얘기를 해볼 텐데요. 안타깝게도 지금 우리가 사용되고 있는 전해조 중 100% 에너지 효율을 달성하는 것은 없고 기술의 종류와 수명 주기에 따라서 과도한 열을 발생하고 있습니다. 실제로 이제 우리가 사용하고 있는 전해조 시스템들은 20에서 40% 정도의 열 에너지가 외부로 방출이 되고 있는데요. 이 안정적인 시스템을 위해 열 관리는 필수적이고 에너지도 회수돼야 될 것입니다. 그리고 전해조는 동시에 이제 다량의 초순수가 사용이 되고 있는 것을 여러분도 잘 알고 계실 겁니다. 전해조에서 발생되는 열 에너지를 관리 또는 회수하기 위해서 그리고 고효율, 그리고 공정 조건에 적합한 열교환기가 필요할 것이라고 알파라발은 주장하고 있습니다. 알파라발은 전해조 공정에서 두 가지 타입의 열교환기를 제안드리고 있는데요. 산업에서 많이 보셨던 것 같이 가스켓 타입 판형 열교환기, 퓨전 본디드 판형 열교환기입니다. 두 제품 모두는 이제 판형 타입이기 때문에 높은 열 전달 계수를 가지고 있으며 냉각 효율을 최적화하고 전해조 성능을 극대화할 수 있는 장점을 가지고 있습니다. 그리고 소형부터 대형까지 다양한 공정의 요구 조건을 유연하게 만족시킬 수 있습니다. 그리고 이제 앞서 전해조를 운전하려면 이제 담수가 필수적이라고 말씀드렸는데요. 실제로 약 10메가와트 규모의 전해조에는 일당 50에서 60세제곱미터의 물이 필요하다고 알려져 있는데요. 알파라발은 전해조에서 버려지는 폐열을 사용한 담수화 솔루션을 제안드리고 있습니다. 이 하이듀오라고 불리는 알파라발의 열 담수화 장비는 역담수화 방식과 비교하면 훨씬 더 컴팩트하고 수처리에 화학물질을 거의 또는 전혀 사용하지 않습니다. 이 장비는 알칼리와 PEM 전해조 모두에 적합하고요. 설치 공간도 작고 증발을 이용한 특성 때문에 전체 시스템의 효율을 이용하는데 아주 유리합니다. 더불어 이제 과열된 열을 사용함으로써 전력 소모가 적고 그다음에 유지 보수에 큰 신경을 쓰지 않아도 된다는 장점이 있습니다. 알파라발은 앞서 설명드린 장비 외에도 여러 가지 장비들을 함께 공부드릴 수 있는데요. 가장 눈에 띄는 것은 프린티드 서킷 익스체인저, 초고압과 극저온의 절교한 열교환기입니다. 그리고 에어타입 열교환기도 산업에서 활발히 사용되고 있습니다. 몇몇 전해조 사례를 설명을 드릴 텐데요. 요거는 독일의 티센그룹에 설치된 파일럿 전해조 설비입니다. 사진에서 확인하시기 조금 힘드시겠지만은 전해조 곳곳에서 열교환기들이 폐열을 활발히 회수하고 있습니다. 다음은 이제 사우디 네옴 프로젝트의 이제 사례인데요. 네옴은 태양광 및 풍력 발전으로 4기가와트의 재생에너지를 생산하고 그 중에서 약 2.2기가와트 규모의 수소 및 암모니아 공장을 건설하려 계획 중입니다. 그래서 이 공장에서는 하루 약 650톤의 수소를 생산할 계획인데요. 저희 알파라발은 여기 BOP 냉각부터 전체 냉각 시스템을 공급을 하고 있기 때문에 전 세계 가장 큰 공장을 커버할 수 있는 능력을 가졌다고 반증드릴 수도 있겠습니다. 다음은 이제 퓨얼셀 분야에 대해서 설명드릴 텐데요. 퓨얼셀 역시 연료전지와 마찬가지로 시장에 큰 관심을 받고 있는 분야입니다. 퓨얼셀 역시 안타깝게도 열교환 효율이 썩 좋지 않은데요. 알파라발은 공정 곳곳에서 폐열을 회수해서 다시 유용한 곳에 사용하는 방법을 제안드리고 있습니다. 역시 여기에도 다양한 열교환기들이 사용이 될 텐데요. 여기서 제가 강조하고 싶은 부분은 알파라발은 공정에 적합한 열교환기를 개발해서 공급을 드린다는 점입니다. 맨 오른쪽 기계에 보면은 이상하게 구멍의 크기가 하나 큰 기계를 보실 수 있을 건데요. 이것은 공기 중에 있는 폐열을 회수하기 위한 장비로서 알파라발이 시장을 어떻게 바라보고 있는지를 명확하게 보여주는 장비라고 볼 수 있습니다. 다음은 이제 수소 충전소 분야에서의 이제 효율 향상이나 안정성에 대해서 말씀을 드릴 건데요. 다들 이제 인지하고 계신 것 같이 수소 분야는 이제 운송 분야가 사람들의 관심을 많이 갖고 있는 분야입니다. 이유는 이제 전기차가 가진 한기 때문인데요. 알파라발이 공급하고 있는 수소를 냉각시킬 수 있는 이제 하이블럭이라고 하는 제품은 최대 1250바까지 그리고 마이너스 70도의 운전 조건에도 적용이 가능하며 기존 쉐렌 튜브 열교환기보다 약 85% 적은 풀프린트만 요구가 되는 겁니다. 이 하이블럭은 여러 가지 용량별, 쿨런트 종류별 제품을 제공하고 있으며 액화 수소에도 적합한 PCH를 저희가 엔지니어링을 통해 공급을 드릴 수 있습니다. 다음은 이제 파워2X에 대해서 설명을 드릴 텐데요. 파워2X는 수소 분자를 이제 다른 형태로 전환하는 모든 것을 의미하며 탈탄소의 핵심적인 요소라고 알파라발은 생각하고 있습니다. X의 대상으로는 암모니아, 메탄올, 메탄 등이 산업에서 주요하게 얘기가 되고 있는데요. 알파라발의 고효율 열전달 기술과 다양한 장비들로 고객들은 파워2X의 생산 비용을 최적화하실 수 있습니다. 이 메탄올은 암모니아에서 가장 널리 고려되는 파생물 중에 하나인데요. 메탄올은 선박 추진용 주요 연료로서 또 더불어 비료 산업의 화학 물질 또는 에너지 운반체로 사용될 수 있습니다. 알파라발은 메탄올과 암모니아 두 공정 모두에 오랜 경험을 보유하고 있는데요. 알파라발은 잠시만요. 보시 하버 공정 안에서도 안정적이고 효율적인 공정 운영을 도울 수 있습니다. 압축기용 증기 발전기, 반응기용 인터체인저, 암모니아용 응축기, 열애수 및 모든 것을 최적화할 수 있는 경험과 장비들을 보유하고 있습니다. 넘어가도록 하겠습니다. 이 메탄올 역시 이제 시장에 큰 관심을 받고 있는데요. 이 메탄올은 그 해양 산업에서 그 에너지 운반체로서 그 더 깨끗한 추진 연료로 활용될 것으로 알파라발은 보고 있습니다. 알파라발의 고효율 열교환기는 메탄올 공정 안에서도 안정적이고 효율적인 공장 운영을 지원하고 있는데요. 역시나 압축기용 증기발전기, 피드 인터체인저, 퍼지 냉각기, 제비기, 응축기 등을 최적화하여 열교환 효율을 높이고 공정의 경제성을 높일 수 있겠습니다. 파워2X 공정에서도 알파라발은 공정의 특성을 온전히 반영하고 있는데요. 화면에서 보시는 장비들은 대용량 장비로서 파워2X만을 위한 적합 파워2X만을 위해 데디케이트돼서 적용된 장비라고 설명드릴 수 있겠습니다. 이제 파워2X의 사례를 한 가지 소개해드리고 싶은데요. 리퀴드 윈드라고 들어보셨을 겁니다. 지멘스 에너지, 톱소, 카본클린이 파트너십을 결성하고 이 메탄올 공장을 설치하려는 프로젝트인데요. 현재 건설 단계에 있으며 올해 말 또는 내년 초에 상업화를 달성할 것으로 기대하고 있습니다. 이 공장에는 약 10만 톤의 이 메탄올을 생산하는 목표를 가지고 있으며 연간 1,400만 톤의 CO2 배출량을 줄일 것으로 예상하고 있는데요. 알파라발은 리퀴드 윈드 프로젝트에서 열 균형 및 에너지 최적화를 보장하고 있으며 주요 장비들을 공급하고 있습니다. 지금까지 알파라발의 다양한 아이디어와 장비들을 개략적으로 소개시켜드렸는데요. 알파라발은 고객사의 안정적이고 효율적인 공정 운영을 돕기 위해 여러 가지 아이디어를 갖고 있습니다. 알파라발에서 공급하는 공정에 최적화된 장비들을 통해서 제품 경쟁력도 확보하시고 친환경에도 기여를 해주시길 기대하면서 저희 프레젠테이션을 마치도록 하겠습니다.
네,
감사합니다.
감사합니다. 네, 지금까지 알파라발의 사례와 제품 함께 만나보셨습니다. 자, 이어지는 발표는요. 미국 텍사스주 휴스턴에 본사를 둔 청정수소 가스 전환 기술 회사 유틸리티 글로벌 회사의 발표가 있겠습니다. 블라디미르 노박 CCO님께서 발표해 주시겠는데요. 네, 큰 박수로 맞이해 주시기 바라겠습니다.
안녕하세요. 제 이름은 Vladimir Novak입니다. This is as far as my Korean will go. We'll have to transition to English now. So, just to repeat, Vladimir Novak. It's a great pleasure to be here and present to you about utility and our technology and solution to economically decarbonize industrial and hard-to-abate sectors. As I start in, I'll use this first slide just to kind of give you a high-level overview. What you are seeing is our H2Gen system, hydrogen generation system, and it has only 2 inputs and 2 outputs. As you can see in the middle coming from the left, water comes in, it will become steam at the temperatures the reactor is operating, and that water will be converted to pure hydrogen. The other inputs are different industrial off-gases, like in steel or refineries, petrochemical, or biogas. We can use many different gases as the source of electrochemical energy. Those gases will convert to high concentration CO2. What we do in our reactor is electrolyze water into hydrogen without using external electricity. and that is the breakthrough in technology and the innovation. We are targeting hardest to abate sectors, hardest to decarbonize sectors, including steel, heavy-duty mobility, refining, petrochemical, chemical, and even upstream oil and gas. And as I go through the presentation, you will see how we do that. All right, so we'll play a video about 3 minutes long. It will give you a visual representation how the technology works from a molecular level all the way to major capital projects. So let's see if the next click will do it. Yeah, it did. All right, so very modular, scalable, and commercially ready. This is a tube that I have here. It's about 90 centimeters long. It's a ceramic metal construction. It has 3 coatings on the outside, cathode, electrolyte, and an anode. Inside the tube, steam flows. Outside is some type of off-gas. What we use here is a typical one in syngas, CO. So from the inside, we'll have water molecule come and touch, and it will be reduced. From the outside, we have CO2 being oxidized. Electron ion leaves the water, comes to CO, and 2 electrons are kicked back to complete the reaction. And those 2 electrons are doing electrolysis of water without external electricity. We essentially make small electricity inside the reactor. So again, zoom out to this tube that I have here. When you hit it, you can kind of hear the ceramic-y sound. How we scale? We put that one tube into pack, and then put many packs into a pressure vessel about 5 bar, so low pressure. First shell that comes is a single reactor. This here shows a bigger system of 5 reactors together. If you want to build bigger, you'll put another train of 5 reactors together and grow up just like a building. It is always off gases coming in on one side, leaving as high concentration CO2, up to 95% concentration CO2, and water as steam coming to the other side, leaving as hydrogen. These 2 streams never mix, so our hydrogen is pure at the end. Again, view inside the reactor, showing a couple of modules, just to show you how simple it is. It's like a cross flow in a heat exchanger. Nothing moves in the reactor except the flow of fluids. So let's see at our very first project, which happened in the steel mill in Canada, a company called Stelco. This is where we made hydrogen blast furnace off gas in one step, not using electricity and high concentration CO2. To scale this up, like you can see here, 2 trains on top of each other next to a blast furnace. So we always need to be next to existing industrial sites, assets, and we allow them to decarbonize by giving them clean hydrogen, no additional CO2 addition to make it, and high concentration CO2, which is lowers the cost for capture and utilization or storage. We can do this next to a bio plant, we can do it next to a refinery. All of those are ideal markets for us. And that much about the video. We'll now go back to the presentation. But this is our business. We help companies decarbonize, in turn, environmental challenges to actually business advantages. Oh, that was pretty smooth, all right? The clicker works. All right, this is our presence. The darker blue countries are where we have projects ongoing. The orangey triangles are where we have offices, so very happy to say that we incorporated in Korea earlier this year. So we have employees here and an office. Korea is a very strategic region for us. In addition to that, we are headquartered in Houston. We are an American company. Research center is in Denver. And we have projects in the US, Canada, and Brazil, India, Korea, and Japan. We are probably going to announce very soon some projects in Europe as well. You can also see on the left side our owners. So Aramco, the largest oil and gas company, is one of our owners. ArcelorMittal, the second largest steel producer, is our investor and have a board seat. Samsung is one of the investors. And if I point to the very top, our partners, they are a private equity fund from the US. They have about 25 companies in their portfolio and a $6.6 billion managing under those companies. And then to the top, that would be right for you. We had an announcement earlier this year with Hanwha, doing Hanwha E&C, doing a pre-feed feasibility study for wastewater treatment, biogas for production of clean hydrogen targeting mobility. Since Korea is such a power country for hydrogen mobility, having more than 40,000 vehicles already on the roads, very impressive for many parts of the world. Last year at the same conference, we got Innovation Award, which was great. This is also the first time we met some of our partners I will mention later on in the presentation and started market entry and a very successful project pipeline. And then finally, so nice to be recognized in Time as one of the green companies for this year. So it was a very exciting year for us. These are our markets. We started with steel and mobility, where we already have projects that I mentioned, and now we're entering new markets, including refining, petrochemical, chemical, and upstream oil and gas. Korea is very good market for us, and we plan to grow our business here substantially. Out of all these markets, when you take together, they have about 50% of CO2 emissions totally. We can easily address at least 20. We can remove 20% of the hardest to abate sectors, which is exactly the core value proposition we have and a goal we will strive to do. To that point, earlier this year, we had 3 advisors to the board that joined us. So starting with Dr. Henrik Adam, who used to be the CEO of Tata Steel Europe and also ThyssenKrupp Electric Hydrogen, currently is the president of European Steel Association, very influential man, particularly in European steel. At the bottom, you can see Tetsuya Shoida, who just retired from Nippon Steel after 40 years, been responsible for decarbonizing activities in Nippon Steel for the last 10 years. So we managed to hire him when he retired. Great addition. And then at the top right, Eric Duchesne, former executive of Total Energies, head of capital projects for the whole company, execution and operations. And earlier in his career was also the CTO for downstream businesses. So he's helping us get traction with the new markets, refining, chemical, petrochemical. We have announced on the right side a project with ArcelorMittal already in Brazil and Mass Energy in California. That's biogas, dairy farm biogas to hydrogen, deeply negative carbon intensity hydrogen, and they're the largest biogas producer in the US. There will be some new projects being announced very shortly, one in India and a couple in Japan, ranging from 10 ton of hydrogen production to over 60 ton of hydrogen production, so getting to really nice scale. On the left side, you can see our activity in Korea, as I mentioned with Hanwha E&C, pre-feasibility study. Then we signed a joint development agreement with Hanwha that came as an introduction to our other partner. We have GH here, so growing a very nice set of strategic partners in Korea to grow. The next project, Sangnam project, which is where we are doing the very first demonstration and certification in Korea. This is essentially official market entry into the country and very important to get the certification so we can do many other bigger projects. And then at the top is the project we just commissioned in the US. This is the latest project. If anybody wants to come see it, it's next to our headquarters, so you're welcome to come and see. I'll have a little bit more about that in a short bit. And Korea, so amazing biogas for hydrogen market. We actually have a pipeline of projects of 13 of them. Korea being so focused on biogas conversion to hydrogen, very good policy put in place, government support, very high targets and goals for the country to achieve. So it's a perfect really scenario for us to help the country and also able to introduce our solution. We have very important partners here. As I mentioned, GH, whom we met at this conference last year and started the relationship. They introduced us to Hanwha, third largest EPC company in Korea, and now we are growing the pipeline and the projects for execution. When you look at Korea, it's a superpower in refining. It has very huge presence in steel. So we have solution how to decarbonize these sectors. we just started with mobility and biogas because that was very natural for us to look for solutions there. What you're seeing here is the very first project we done in steel in Canada that I mentioned with Stelco. So that really puts us on the map and proves to the customers that our technology is real and can do what we say it can. This is the Frontier in Houston. If you remember the video as well as the first slide I showed you, you have a cylinder pressure vessel about 5 bar. You can see on the left there the pressure vessel, exactly like that. It's just shorter, not as long as a full-size commercial, but otherwise identical to commercial. So this is for our customers and investors to come and see anytime they want. So if you are willing to travel to Houston, just let me know and we can host you. Once again, just to give you a sense how simple this is, starting with a single tube electrochemical cell, about 90 centimeters long. We put many of them in a pack, put those pack in a pressure vessel, and that becomes our reactor. It's a very standard size, 12 meters or 40-foot reactor, so kind of a shippable container size, which was done on purpose so we can move them around very economically. And then when we want to go bigger from a single reactor, mobility project would be a single reactor, typically, biogas project. The total footprint with balance of plant would be 25 meters by 15, very small. And then as we go to bigger projects, that's even better. This you can see here, 70 meters. There are 2 trains. This can produce up to 60 tons of hydrogen a day. Very small footprint. And to compare typically 2 technologies that we are competing, so one would be electrolysis using electricity. We just don't need electricity, and this slide emphasizes that. Typical electrolysis at the top, when you have anode, electrolyte, and a cathode, you do need a lot of electricity coming usually from a power plant, could be a solar field, could be a wind farm, could be just grid to make hydrogen. We do not require that power from outside. We take electrons from the gases that are our electrochemical source. And that is the difference, that is the innovation. It's enabled through this special electrolyte that is mixed conducting. It can conduct 2 things, ions of oxygen one way and electrons the other way. And that is our intellectual property. If we go to steam methane reforming as another and major way of making hydrogen, for them to make hydrogen starting, for example, for biogas, they would need to upgrade that biogas to biomethane, so they need to split CO2 from methane. We do not need to remove CO2 before it goes into our reactor. So any inerts can go through our reactor without any problem. Then with SMR, you end up having hydrogen mixed with other gases, which would be nitrogen, CO2, and you have to separate it. We make hydrogen directly from water, so we don't have that separation step. We just condense the water, which is very easy to do. And we get pure hydrogen. 5 nines for mobility, easy to achieve for us. This gives us an advantage to be more economical than SMR and much smaller footprint as well. And to summarize this all in one picture, many different off-gases coming into the reactor, be it process gases, off-gases, biogas, we can use them all, and just water, which is just softened water, nothing special about it. In the US, we go to Home Depot, buy a softener for water, and that's what we use. That will give you pure hydrogen that can be then used in mobility. Think of this as decentralized, distributed hydrogen production. In Korea, 14 projects, bankable projects, so economics work really well. In steel, we are able to allow customers to make green steel and not increase the cost of their steel. Very good value proposition to them. And refining and chemicals, this is where we can achieve up to 95% CO2 concentration. So essentially that CO2 is ready for capture, very low cost to capture it and then utilize it, making SAF fuel or e-methanol together with hydrogen that we make. So this is very attractive to customers as well as investors. And that is the value we bring to help decarbonize hardest sectors, industrial sectors. And that's my last slide, just a quick view of the company. Many different companies that we have people worked prior to join us. A lot of experience in commercializing new technologies and doing major capital projects. And we are ready to do this again in Korea. Thank you very much for your attention. And If you have any questions, please find me. You're welcome to come to our booth. It's in the back where the copy shop is, or third booth to the right from Hyundai, which is a really big booth, so you cannot miss that one. And with that, I will complete my presentation and try to do one more time my Korean. So, 감사합니다.
네, 고맙습니다. 유틸티 글로벌 회사의 기술을 확인할 수 있는 시간이었습니다. 네, 이어지는 발표에 앞서서 잠시 브레이크 타임을 갖겠는데요. 특히 발표 자료집 PDF 파일이 필요하신 경우에는요. 네, 지금 QR 코드 보여드리겠습니다. QR 코드에 접속하셔서 다운로드 받으시면 되겠습니다. 네, 잠시 한 10분 정도 쉬는 시간 가질 예정이니까요. 네, 지금 28분입니다. 38분까지 자리 함께 해주시면 감사하겠습니다.
인류는 끊임없이 도전하는 사람들로 인해 발전해 왔습니다. 국내 1위 도시가스 사업자에서 민간 기업 최초로 LNG 밸류 체인 완성까지. 여기에 안주하지 않고 우리는 또 다른 도전을 계속하려 합니다. 차별화된 사업 포트폴리오로 만들어가는 지속 가능한 미래 에너지 세상. 불가능을 가능으로 바꾸는 도전. 그 여정에 함께해 주세요. SK 이노베이션 ENS가 앞장서겠습니다. 미래 에너지에 답하다. SK 이노베이션 ENS.
이제 안으로 입장하셔서 자리에 앉아 주시기 바랍니다. 이번 세션의 첫 번째 발표는요. 3M의 옌스 아이흐 하이드로젠 테크놀로지 앤 비즈니스 아키텍트이신 옌스 아이흐 발표 분님께서 발표를 해 주시겠습니다. 박수로 환영해 주시기 바라겠습니다.
Yeah, thank you. Yeah, let me introduce myself. So my name is Jens Eichler. I'm, as you already said, a hydrogen technology and business architect in 3M. So you can see I'm a scientist, I'm a material scientist, but I'm also looking at the hydrogen economy from a business building perspective. So I have two views on the hydrogen economy. And with my talk, I want to bring those two things together. So the hydrogen economy is very much about material science questions, but on the other hand, we are also still building an economy here, so it has to go hand in hand. If you look at 3M, it has a long tradition. We have over 100 years that 3M already exists, and you can see that when you look back, it was always about innovation. And you can think about the innovation model of 3M and how we reinvented ourselves over and over again. And so a couple of years back, about 4 or 5 years ago, 3M was looking into energy as one of the growth vectors when you look into the economy. And you can see that the investment is broad-based. I mean, we are looking into carbon capture. We are looking also into how you can reflect back waves into the atmosphere so that we can, for example, cool buildings or cool vans. And then on the right-hand side, you can also think about what effect will climate change have, for example, on growing our crops. So maybe we have to manage heat in a different way. But what I want to talk about here is hydrogen economy. And this is one of the topics, of course, that I'm most involved in. If you think about the innovation model of 3M, it comes down to what you see on the upper right-hand side, our 49 technology platforms. So it's important to understand that 3M never starts, let's say, with a new invention from scratch. We normally can rely on things that we have already developed in the past. And I want to give you one example here in adhesives a little later on. But it's also about our collaboration culture. It's about the insights and the end, the customers at our core. Of course, we have to understand what the challenges of the customer are for us to be successful. If you think about the hydrogen economy, it's not just about the customer, it's that we are still, and I was part of the Hydrogen Council COE meeting earlier this week, we as an industry are still trying to build this economy. I mean, of course, there's already more than 100 million tons of hydrogen used today, gray hydrogen coming from natural gas that is used for ammonia and for refining industry. But if you think about, and that's on the upper left-hand side, but if you think about other forms of hydrogen, green hydrogen, blue hydrogen, this is still a very new industry. And of course, we are also looking for new use forms of hydrogen, because we don't just want to use hydrogen in the ways that it is used today, for making fertilizer, for refining oil and gas. No, we also want to use it for other causes. We want to use it for mobility. And what I think is always important to say when you're thinking about hydrogen, we also want to use it as a chemical reactant. Because very often people just think about hydrogen as an energy carrier, but I think it's also important to point out that we maybe want to use it for green steel or for other ways. So just keep that in mind when you're thinking about the hydrogen economy. If we look at this, if I look at this map, I see all kinds of material science challenges. So if you think about and you look at this, you're going down to minus 253 degrees Celsius if you use liquid hydrogen. If you go into solid oxide, it is 750 degrees Celsius. You have a pH of 1, you have a pH of 14.8 in this industry. So there's a lot of very interesting material science questions. And for me as a material scientist, of course, this is what drives me, as well as hoping to help this industry to grow with our solutions. So if we are looking at a customer problem here, or an industry problem, first of all, we have to understand what the challenge is. And I'm always, again, as a material scientist, we are trying to break this down into material science questions. So is it, for example, a chemical stability? Is it an electrical resistance or electrical conductivity? And so on and so on. So we have to take this fingerprint and then translate this into our technology platforms. And very often, when you come to the point and you want to create a product, it's about optimizing two things. So you have to make a compromise in some way. And so this is what we as material scientists in 3M are trying to do. So here's one example. If you think about a very traditional product of 3M, and you can also see it at our booth here, that we are showing you what we call the bonding continuum, all the different adhesives that we have available. If you go on the left-hand side, you can see in a fuel cell or an electrolyzer, there's up to 6 positions where you could potentially use an adhesive. Maybe today you would just use, or you would use a seal, so it's not having an adhesive performance, but in the end, I'm always telling my adhesive colleagues, maybe for us it's an adhesive, but maybe for our customers it's a seal. So it could be both, depending on how you use it and how you operate with it. So we looked, as I said, at the bonding continuum that you can see in the middle, and then we asked ourselves, so what's different about the hydrogen economy? One thing I learned when my previous project was in automotive electrification, is that if you move from smaller scale production to larger scale production, you have to think about automation. So that's the first step. The second thing is, when you're looking into the hydrogen economy, you have some specific things that only apply to hydrogen overall. This is, for example, hydrogen permeation. So you have to think about, is your material, let's say, permeating hydrogen, or is it stopping hydrogen to leak out? Because hydrogen, of course, has a danger potential to it, but it also has a secondary global warming potential. So we shouldn't be shy about pointing out that hydrogen also, we have to make sure that we are not losing any of it. And then the third part is that in the application, you have some specific requirements, as I pointed out. So then we looked into our materials, our adhesives, and we tested them, and you can see already down here, I will come back to the slide in a second, that we have a couple of materials that we think are probably pretty good. So breaking this down again, on the upper left-hand side, you see the low hydrogen permeation, and we tested this with an external institute. You can see our typical materials, epoxies, polyurethane, acrylates, silicones. Silicones are widely accepted for fuel cell applications. So anything we are using here has a lower permeation rate. So that's already good. One aspect that is always a little bit more difficult to judge on is what is happening. Is there any poisoning effect of the materials? Is something leaching out, or is there any volatiles? So this is on the upper right-hand side. So this is something you have to do with your customer. On the lower left-hand side, we have been looking into the chemical and thermal stability. I come to that in a second. And then I think the last point is creep stability. If you think about electrolyzer today, The main maintenance circle that the companies have to go through is that they have to retighten the screws because the seals are creeping. So creep resistance is definitely a challenge in the industry. So after all this testing, we came up with a couple of solutions that we think are definitely a good starting point. So if any of you here in the room is interested to look into adhesives and sealant in the hydrogen economy, we're more than happy to discuss with you, and these are all existing products of 3M. So we can have a conversation and we can see if these are already fitting your needs. But we're also aware this is not the end of the discussion. We also know that we have to go further. And what we do here is in a public funded project with Forschungszentrum Jülich and RWTH Aachen in Germany. We are looking into the stack design because in the end, as I pointed out, it's not just about the material, it's about the combination of material, process and design like we saw in the automotive electrification industry some years ago. And so with that, you can see on the right-hand side, we're currently discussing, in this case for anion exchange membrane, how we can make a difference in this industry. But, of course, there's more. And since we're here in Korea, I want to specifically point out a few other material science challenges that we are working here with the team also very closely with the industry here. So glass bubbles is one additional opportunity here. And there's colleagues here in the room who are very much involved in that, where we're working with KSOE, for example, here with the chip builder in Korea to bring glass bubbles into the liquid hydrogen tanks that hopefully will bring also liquid hydrogen to Germany at some point. So the idea behind this is that you need to insulate the outside of the shell. So basically like your thermocouple, you have an inner and outer wall and you can draw a vacuum, but the vacuum will only take away one portion of the thermal radiation or one part of the thermal conductivity. You will still have heat radiation going through, and you need the glass bubbles basically to block that. And you can see the NASA tank on the left-hand side, and you can see here some data from NASA that showed that our glass bubbles are the best solution for that, for these large tanks. It's a little bit too much here, but please come to our booth if you're interested. The colleagues are more than happy to discuss this with you further. But if you're already looking at liquid hydrogen, it can also be a very interesting challenge if you want to combine things. So we have an adhesive at 3M that is operating at minus 253 degrees Celsius. We've proven this already. This is already a legacy product. I was joking at some point this might have been developed for the Apollo program. A colleague told me this was actually developed in the 1960s. But this is a very robust and very good adhesive that works even today in these applications. Also, if you're thinking about other low temperature applications in space, or if you're thinking about quantum computing, maybe this is a starting point. And then, as I pointed out before, maybe we have to adapt it in some way. But this is what the 3M scientists can do then. And for me, as a material scientist again, what I find interesting is that if you go to very low temperatures, I'm a ceramicist. This is for my PhD thesis on the left-hand side. You see the arrow, this is actually where the fracture originated. So you can see this is the fracture origin. And then it branched out, and then you can see here, it's a little bit more difficult to see on the left-hand side. It's like a map, so you can track back where the crack originated from the beginning. This is from our adhesives for these cryogenic temperatures. And we also did a similar fracture test. And what you can see now is also there's these lines that are basically indicating where the crack originated. You can see this very smooth area here, which is called the fracture mirror. And so you can see that in our case, an air bubble was the reason why it failed in the end. So we can apply our knowledge about ceramic materials and about fracture mechanics also to this field and improve our materials here. So I think there's a lot we can leverage in the hydrogen economy from other fields to solve the challenges that we might face. The last one I want to point out here, because I saw also down in the exhibition, there's a lot of tank manufacturers that we are currently in the process of bringing one of our products that we've already developed in the past back into the market, and that is a matrix resin for these composite tanks. The beauty about this is that basically if you bring it so you can see these are the carbon fibers, and then you can see our matrix resin here with some fillers in it is coming in between. It helps to basically transfer more strength among the fibers. And it's helping in the end that you can either make a thinner wall or you can make more room for your hydrogen in your compressed tank. So it could be a solution to make it more commercially viable. And I know in the EU, for example, they were lowering the standards, how much more of a safety factor you have to put on your hydrogen tank. So I think this can definitely enable to make a hydrogen tank more commercially viable. So also if you're here, please come to our booth. We are happy to discuss this in more detail with you. And then finally, there's all kinds of other products of 3M that you can find all across the value chain, starting from coatings that can go on pipelines on the inside or on the outside, for example, to increase the flow of hydrogen. We can think about compressors. We have seal rings that go into compressors for natural gas today, but maybe also hydrogen in the future. We can think about our silicon carbide materials, which have a very universal corrosion resistance, which can help you to have pumps in your balance of plant for the alkaline systems. And then finally, we have our Nextile fibers, which operate at high temperatures, which is not just for solid oxide, but maybe also for other steam methane reforming and other ways where you have high temperatures up to 1,300 degrees that can maybe help to solve some of the material science challenges there. And so in summary, if you're interested in any of these topics, please come to our booth or feel free to scan the code to get more information. Thank you for your attention.
네, 감사합니다. 3M의 저장 기술에 대한 인사이트를 얻을 수 있는 시간이었습니다. 고맙습니다. 다음은 리퀴드 ELC에서 준비해 주셨습니다. 프랑스 다국적 기업으로 수소 생산과 저탄소 수소 기반 에너지 솔루션을 설계하는 회사인데요. 네, 발표 박수로 청해 듣겠습니다.
Hello, good afternoon, everyone. So my name is Sébastien Lechelet. I'm the director of the liquid hydrogen product line in Air Liquide Engineering and Construction. And very happy, very glad today to discuss about large-scale hydrogen technology to enable intercontinental hydrogen transportation. So why are we talking about intercontinental transportation? The first things, we know that we have a quick growth of clean hydrogen. So today we are about 1 million tons per annum. We learned that we have 5 million tons per annum already committed, and that makes us in 2030 having about 10 million tons per annum plus clean hydrogen. This is the first statement, so we are very happy with that. Second statement is that the need and the demand and the ability to produce this clean hydrogen is unbalanced around the planet. So you have countries like the US or Australia that have a very good condition to produce clean hydrogen or derivatives. And you have other parts of the world like Europe, Japan or Korea that are demanding, that have a high demand for this product, but have less capacity to produce it locally. So that's, let's say, the background. So now talking about the progress, where we stand on this subject. So in the last years, we have already had the first intercontinental LH2 shipment a couple of years back. That was the Japan-Suisso Frontier boat ship. We have also the startup of very large liquid hydrogen plant here in Incheon, 90 ton per day production, so designed by Air Liquide. The techno was provided by Air Liquide. Tomorrow, what we see that we are going towards 100 ton plus LH2 trains. We also have the increase of the liquid hydrogen capacity, and we see major oil and gas producer and others thinking already of mimicking the LNG business and market. So Air Liquide, who are we? So we are, let's say, involved in hydrogen for more than 60 years. So we have experience in the technology, we have experience in the business. So this, we are talking about production, primary production, electrolyzer, reforming of fossil fuel. capture of CO2. So we are in the green production and in the blue production of hydrogen. Of course, we will come back to this. We have the technology to liquefy this hydrogen. And after, we are also very present in the downstream part, in the mobility and distribution. So today we will focus on this part, let's say green production and liquefaction. So a word about electrolyzer. So as you may know, Air Liquide has been, pioneering the PEM technology. We were operating in Canada since about 5 years now, a PEM techno in Bécancour. And this has been growing very fastly. So today we are building 2 plants of 200 megawatt in Europe, in Normandy. One of them, another in Rotterdam. And we are also now contemplating with our partner even larger one, 250 megawatt. Also worth being seen, we are so now focusing on the PEM. We have a joint venture with Siemens on this technology, but we have been operating other type of electrolyzers such as alkaline, for example. Now, regarding liquid hydrogen production. So we are a leader, one of the leader of the liquid hydrogen production. We are operating, for example, 10 ton per day plant, which is a 40 years old plant that's been designed and started up in 1987. We are more recently started up in Nevada, USA, a plant of 30 ton per year. And so this is operated by Air Liquide like many other plants. But we also provided the technology to other customers. So, and here a special spot for South Korea, where we have a 5 ton per day technology installed in Changwon, and as I already mentioned, 19 ton per day here in Incheon. So the world largest H2 liquefaction plant. So this capacity is already approaching what is needed for large scale. So that's really a great milestone. So now talking about milestone, I will focus on what we believe is needed to unlock further this large scale and intercontinental supply chain. So upstream, as I said, you can have green or blue hydrogen. We will not come back on that one. The second part, of course, once you have produced your hydrogen, you need to liquefy it to be able to transport it efficiently. So one question is, what is the right size to do so? How far do you have to scale up this technology? And another important point is also the downstream. What is happening downstream with the boil-off gas management? So when we are talking about transferring large quantity of liquid hydrogen, as you may know, this liquid, which is cryogenic, tends to vaporize, similar to LNG. And we really have to find a way to manage this bug, to avoid losing the molecule, and of course to increase the economical interest of the supply chain. And finally, I will have a talk about managing intermittency. This is also something very important when you are connected to green and let's say green supply of energy and hydrogen that will move with the sun or the wind. Okay. So first topic, scaling up. So now, as I said, we are basically having a state-of-the-art technology ranging from 1 to 60 ton per day. We have already, as I said, multiple trains operating for 30. This technology can be extended to 60. This is commercially available. And such type of processes are basically using 2 big refrigeration cycles. So first one typically using nitrogen as refrigerant, another one using hydrogen itself as a refrigerant. And thanks to this, the cooling duty which is generated by this cycle, you can transfer the cold to the hydrogen feed in order to liquefy it. So what is very key when we talk about liquefaction is the two main, I would say, the key equipment are the compression and the expansion. So so we, Air Liquide, own nitrogen expanders. We are manufacturing it by ourselves. Same thing for the hydrogen expanders. So these ones are really the key one to upscale the technology. If you don't upscale those one, you will end up with multiple machinery, which is not, let's say, optimum to reach large capacity. Second thing is the cold boxes. So these are the main equipment that are allowing to transfer the cooling duty to the hydrogen. So you typically have two cold boxes, one calling 80K, so you go to 80K Kelvin, and another one going to 20K Kelvin. So same thing, these ones are manufactured by Air Liquide. That's where we have most of our skills, and that's why we are really able to upscale those critical equipment. So the next step is now a capacity of 60 to 150 tons per day. So this has been done, as I say, by increasing the size of the turbine, but also by implementing new system of energy recovery. So the turbines are now coupled with a system that can recover the energy, the work that has been done during the letting down the gas. Another technology here is a liquid turbine. We have also implemented now a turbine that can allow to further cool down the liquid hydrogen, generating less bug during the storage and transportation. So those are the key items. And of course, you have the benefit of scaling up. So as I said, we manage really these cold boxes scale up, and this helps, of course, the economics of these new trains. And finally, we have just around the corner 150 tons per day. So this we have made a partnership with a major oil and gas to determine what will be the best size of train. And we know that these are in the region of 200 to 300 tons per day. The landing point for major project is to have about 1,000 tons per day production to really mimic the LNG business and have the right cost of molecule at the end customer. So same thing, increasing the compression and expander and make larger cold box even larger to match your cost objective. So all this scale up allows, of course, an important thing, it allows to decrease the consumption of liquefaction. So from 8 to 10 in the current state of the art, we going down to less than 7 kilowatts. So these are significant improvement, knowing that this liquefaction step is consuming a significant amount of energy. Second very interesting point is, of course, we are looking for total cost of ownership of this liquefaction step. Currently on a, let's say, 100 basis, and this one is changing from each opportunity depending on the cost of the power, different aspect of the site. But basically, we expect already the first step, what is commercially available, what we are proposing. So in the range of 100 tons per day, we already decrease by about 40% the impact of the liquefaction on the final cost of hydrogen. So now we are looking forward, 150 to 130. Sorry, this is this one. And after the largest plant to go even below. Okay, so that was for the scale up of the liquefaction train. Another important topic is the boil off gas. So what do you do with this vapor which is generated So this is the liquefaction. You transfer to the tank, then you will transfer to the ship, and each time you transfer, each time you store, you will generate vapor. So currently, I mean, this vapor, when you store, can represent up to 10% of your liquefaction facility capability. So what does it mean? It means that if you want to send back this vapor to the entrance of your liquefaction, you basically oversize your liquefaction capacity by 10%. But also during the transfer, this boil of gas rate can go much higher, like about 15 to 25% more. So this is lasting only a few hours, the time to load a ship, but this is still very significant. So currently we are recycling it, which is a suboptimal solution. What we have developed now is using, so together with our partner, developing operational methodology to, let's say, limit the quantity of bug and adapting, cooling down at the right moment with the right manner all the system to generate the less bug as possible. We will also maximize the ortho-para optimization. I will not enter into details, but if you maximize the para form of hydrogen, you have less bug generated. But on top of that, we have developed a solution to use the subcooling of the liquid hydrogen. So we have a specific technology which is already implemented in more than 200 shipping projects in the LNG business. So we are using it this time for the liquid hydrogen in order to basically have a zero bug solution. So bug is not generated and is remaining between the storage and the shipping. Okay, final part. How do you manage your intermittency? So when you design the full chain, you have to design your source of electricity with the right capacity factor. You don't want to make it too small, so you cannot benefit from the max moment, the best moment of light, for example. But you don't want to oversize it also, because if not, your capital expenditure will be too high. Second thing, the seasonality. So So it changes with the period of the year. So how do you get the right sizing for your liquefier, knowing that you have excess on some time and lack of production in some other? And then you have the daily variability. So how do your assets are changing or let's say adapting to the load? So there is a various set of solutions. They are all very different: battery, oversizing, gaseous buffer. So many things are on the table, but it's not always easy to understand which way do you want to optimize your various solutions. So we have developed in Air Liquide a solution to take into account all the customer hypotheses, all the customer particularity of their site and their opportunity, to modelize what will be the best solution for them and to get the right equipment sizing, reaching the best TCO and having the best operating profile. So that's it for my presentation. Thank you a lot.
네, 감사합니다. 생산에서 운송까지 또 완성형 밸류 체인을 제공하는 기업으로서 그 역할이 더욱더 커질 것으로 기대됩니다. 다시 한번 큰 박수 부탁드리겠습니다. 네, 계속해서 henkel 코리아 심연섭 리드 애플리케이션 엔지니어께서 결합을 넘어 수소 응용 분야를 위한 첨단 접착 솔루션에 대해 발표해 주시겠습니다. 큰 박수 부탁드립니다.
Hello, thank you for coming. My name is Lucas, working as an application engineer from henkel Korea. Actually, I am here in Korea, so it's better to speak with the Korean, okay? So I think the translation service is available, I hope so. So we henkel, I think 죄송합니다. 한국말로 하기로 했죠. 저희 henkel은 이제 록타이트라는 브랜드를 가지고 있고 명실상부 압도적으로 브랜드 1위 파워를 가지고 있다고 말씀드릴 수 있습니다. 이미 아마 이제 다이소나 이러한 그런 문구점에서 순간 접착제를 써셨을 수도 있고 여러분이 나이키나 아디다스 신발을 신고 계신다면 저희 접착제일 거고 아마 LG나 삼성 그런 어플라이언스 제품을 쓰고 계신다면 저희 접착제가 들어가 있습니다. 그러면 왜 수소에 저희 접착제가 사용될 수 있느냐? 저희 henkel은 수소 쪽에 들어가는 그 가장 큰 밸류를 세 가지로 표현할 수 있는데요. 첫 번째는 수소 에코시스템에서 얼마만큼 안전성, 즉 그 누설되는 것을 방지할 수 있느냐. 저희의 솔루션이 첫 번째 키워드가 될 것 같고, 두 번째는 과연 그럼 수소가 입증될 수 있는 접착제와 호환이 될 수 있는 데이터를 확보할 수 있느냐. 그게 저희 브랜드가 가진 또 하나의 장점일 수 있겠고요. 마지막 세 번째는 그러면 접착제를 쓰지 않고 메커니컬 파트로 단순 조립하는 것보다 어떠한 밸류가 있는지 그것들을 포커스하고 있고 그런 점에 대해서 설명을 드리려고 하겠습니다. 지금 보시면 아마 이미 수소를 얘기하기 이전에 저희 록타이트를 사용하고 있는 수많은 고객들의 문제점입니다. 지금 보시는 화면에서 무엇이 보이세요? You can see the left side maybe some leakage issue already in the floor, right? 그거 왜 그러냐면 눈에 보이지 않는 공극, void를 메우지 못했기 때문입니다. 아마 pressed fit이나 shrink fit 아니면 단순 결합만으로는 그 눈에 안 보이는 공극을 메울 수가 없는데 여러분이 한번 생각해 보시면 나사, 볼트와 너트를 조였다. 아주 강하게 조였다라고 하게 되면 실제로는 한 20% 정도만 마찰력으로 잡아주고 있게 됩니다. 그리고 나머지 80%는 공극이죠. 이러한 것에서 시작하는 게 바로 저희 록타이트의 컨셉이라고 보시면 되고 눈에 안 보는 이 공극을 어떻게 메울 거냐? 접착제로 메우게 됩니다. 그러면 저희가 드릴 수 있는 밸류 세 가지를 먼저 좀 말씀을 드리면 맨 왼쪽에 보이는 사진이 파이프 실런트입니다. 파이프 같은 경우에 이것을 이제 누설을 막기 위해서 아마 강제 결합을 하시거나 아니면 테플론 테이프를 쓰셨을 겁니다. 테플론 테이프 쉽죠. 근데 문제는 밸브나 컴프레셔를 만드시는 많은 고객들의 경우에 리얼라인을 하시는 과정에서 나사선에서 찢어져 버립니다. 그래서 원자력 발전소 같은 경우에는 이런 것을 쓰실 수가 없어요. 그래서 록타이트를 쓰시게 되고 리퀴드 타입의 접착제가 눈에 안 보이는 공극을 완전히 메우고 미세 조정하는 과정에서 이러한 이슈가 없습니다. 두 번째는 지금 플랜지에 쓰는 이제 고체 가스켓을 얘기하는 건데 고체 가스켓은 지금 사진에서 보시는 것처럼 디자인이나 사이즈에 맞게끔 다 재고를 가져가셔야 되거든요. 근데 저희는 액상 가스켓이기 때문에 플랜지 디자인 이런 거 상관없이 하나의 제품으로 커버할 수 있습니다. 맨 오른쪽에 보이시는 거는 수소 업계에서 많이 쓰는 콘 앤 스레드 타입일 텐데 이 경우에도 눈에 안 보이는 공극을 통해서 누설이 발생을 하게 되죠. 아마 이 제품들은 저희 브랜드를 가장 알리게 된 가장 대표적인 제품인데요. 이러한 제품들이 수소에서 쓰일 수 있는 첫 번째 이유는 메카니컬 자체가 케미컬 베이스 자체가 수소에 호환이 가능하다는 점입니다. 저는 이걸 현기성 접착제, 에너로빅 어드히시브라고 부르는데 좀 재밌는 기작이 있어요. 첫 번째는 반드시 금속에만 쓰셔야 되고 두 번째는 공기가 차단되어야 됩니다. 여기서 공기 차단은 진공을 만드는 게 아니라 나사나 볼트를 결합하시는 과정, 그다음에 프레스핏과 같은 그러한 상황을 얘기를 하게 되는데 이러한 과정에서 수소에 의해서 저희 제품의 데미지가 장기적으로 없는지, 그다음에 수소가 워낙 분자가 작기 때문에 이러한 것들을 충분히 막을 수 있는지가 관건입니다. 그래서 저희 현기성 접착제는 이미 30년 넘게 혹은 그 이상 한국과 전 세계에서 오랫동안 많이 써왔었는데 이러한 것들을 증명해낸 게 저희의 이제 시작점이라고 보시면 될 것 같습니다. 그래서 배관밀봉제의 경우에 이제 이 제품을 쓸 수가 있는데요. 배관밀봉제, 나사산이 있는 나사 고정제, 그다음에 틈이 존재할 수 있는 플랜지를 결합하는 가스켓 같은 경우에 이러한 메커니즘으로 이제 제안을 드리려고 하는 거고, 그러다 보니까 수소의 경우에는 이제 이송 물질, 수소 자체를 보내는 밸브라던가 컴프레셔, 펌프 이러한 것들에 이미 저희 제품을 전 세계적으로 많이 쓰고 있습니다. 그럼에도 불구하고 많은 고객들이 아직도 접착제를 쓴다는 거에서 굉장히 좀 이제 어려워하시기도 하는데 이미 증명되어 있는 데이터와 저희가 전 세계적인 많은 케이스가 있기 때문에 그러한 부분들을 좀 소개를 드리려고 합니다. 그럼 이런 걸 어떻게 입증하느냐? 첫 번째, 저희는 이미 2, 3년 전부터 데이터를 준비를 해왔고 그러면 그 앞실링이 되는지를 저희가 네덜란드 외부 기관을 통해서 먼저 입증을 해냈습니다. 그중에 5로 시작하는 록타이트 567과 577은 액상 타입입니다. 이 액상 타입의 제품을 밸브와 컴프레셔에 결합을 하고 500바 정도에 견디느냐를 입증한 케이스가 있고 코넨3레드와 같이 타이트하게 적용되는 그런 프레스핏 같은 경우에는 록타이트 6으로 시작하는 저점도 제품의 제품으로 1500바까지 입증한 데이터가 있습니다. 그래서 저희가 이미 플루이드 쪽, 뭐 이미 컴프레셔나 아니면 밸브나 이런 쪽은 입증되어 있는 데이터가 있는데 그러면 고압 실링에도 문제가 없느냐 이러한 것들을 저희 내부뿐만이 아니라 외부 기관에서 공인 인증된 데이터로 제공을 하고 있다는 점 말씀드리겠습니다. 제품이 여러 가지가 있어요. 그 중에서 수소에 가능한 것은 맨 왼쪽에 있는 록타이트 55는 그럼에도 불구하고 액상 타입의 접착제가 싫다. 그 다음에 테플론 테이프는 쓸 수가 없다라고 하는 경우에 사용하실 수 있는 코드 타입의 실이라고 생각하시면 됩니다. 저 제품은 일종의 나일론 제품이 굉장히 가느다란 실로 여러 가지 가닥으로 되어 있어서 찢어지지가 않아요. 그래서 테플론 테이프를 대체하실 수 있는 제품이고 중간에 있는 577, 그 다음에 567 이런 제품들은 액상 타입입니다. 638이라고 하는 제품은 코넨3레드에 쓸 수 있는 전용 제품이고요. 이러한 것들이 실제 현장에서 쓰이고 있거든요. 제가 실제 케이스를 몇 가지 가져와 봤는데 첫 번째 케이스가 실제 해외에서 이제 그 수소 이제 배관을 통해서 퓨일링 스테이션에서 사용하고 있는 케이스인데요. 록타이트 638이라고 하는 제품을 사용함으로써 지금 동그라미 치신 부분에 보이실 텐데 1000바에 해당하는 그 압력 게이지 수시로 오가는 그런 상황에서도 저희 제품을 통해서 실링 퍼포먼스를 냈던 케이스가 있습니다. 두 번째는 가스버너인데요. 수소 그 연료를 이용해서 사용했던 가스버너의 경우에도 저희 제품을 써서 누설을 방지했던 케이스가 있고 이 577 같은 경우에는 좀 재밌는 게 아래 보시는 것처럼 DVGW라던가 NSF-P1과 같은 다양한 케미칼 인증들도 가지고 있기 때문에 엔드 유저에서 요청하시는 경우에 저희가 제공할 수 있다는 점이 좀 특징입니다. 지금까지 말씀드렸던 거는 이제 thread sealing, 결국 나사산이 있는 파이프 배관을 어떻게 메우느냐에 대해서 설명을 드렸었는데요. 지금 설명드리려고 하는 거는 플랜지에 사용되는 겁니다. 플랜지라고 하게 되면 이미 고체 가스켓을 사용하고 계실 텐데 이 고체 가스켓을 아까 말씀드렸던 것처럼 보통 러버 오링이라던가 플라스틱이나 테플론 같은 것을 쓰실 겁니다. 그러면 플랜지 크기, 디자인에 따라서 다 구축을 하셔야 될 텐데 2년이 지나고 5년이 지나서 사갔어요. 그럼 이때는 다시 쓰실 수도 없을 뿐더러 눈에 안 보이는 공국을 못 메우죠. 근데 지금 보시는 저의 액상 리퀴드 타입의 가스켓은 그 크기나 사이즈에 상관없이 한 제품으로 다 커버를 하실 수가 있습니다. 아까 보여드렸던 그 접착제들과 같은 계열이기 때문에 수소에도 사용이 가능한 제품이고요. 이러한 제품들, 그다음 앞에 보여드렸던 제품 모두 다 이미 산업 현장에서 굉장히 많이 사용되고 있고 저희 브랜드 파워를 알릴 수 있는 1등 공신이다. 이렇게 말씀을 드릴 수가 있는데 이 제품도 마찬가지입니다. 눈에 안 보이는 공극, 그 에너로빅 실런트라고 하는 부분이 케미칼적으로 장기적으로 수소에서 이제 만났을 때 큰 문제가 없는 제품으로 알려져 있습니다. 그래서 이러한 제품들은 저희가 수소에 어필하기 전에 이미 자동차 파워트레인이라던가 아니면은 뭐 오일앤가스 현장, 그 다음에 중장비 업체에서도 굉장히 많이 쓰고 있는 제품이고요. 아까 말씀드렸던 것처럼 저희가 내부적으로 이제 테스트를 많이 하기도 하고 외부 기관 테스트도 진행을 했었습니다. 플랜지 같은 경우에는 이제 저희가 3가지 제품을 좀 말씀을 드리려고 하는데 이 제품 각각의 특성은 점도라고 해서 흐름성이 다르기도 하고 어떤 제품은 또 온도가 다르기도 합니다. 내열성이 다르기 때문에 그러한 점에서 고객사가 원하는 상태로 선택을 하실 수가 있습니다. 지금 록타이트 510, 518, 574라고 하는 제품들은 한 40바 내외, 그다음 20바 내외에서 장기적인 테스트를 했을 때 누설이 발생했는지 안 했는지를 저희가 기관에서 테스트를 해서 받았고요. 플랜지 안에 이제 제품을 바르게 되겠죠. 액상 제품을 바르고 접착제가 경화되기 이전에도 초기에 어느 정도 1바에서 3바 내외까지는 실링 퍼포먼스를 낼 수가 있습니다. 그래서 접착제가 경화되는데 시간이 많이 걸려야 되지 않느냐 이런 거에 대한 이슈도 없을 뿐더러 나중에 해체를 하실 때에도 접착제를 썼음에도 불구하고 해체하는 데 큰 어려움이 없습니다. 그래서 접착력, 그 다음에 실링력 이 2가지 부분에서는 조금 다른 부분이라서 실링력에 포커스가 되어 있는 제품이라고 이해하시면 될 것 같아요. 네, 지금 보시는 것처럼 아래 그래프를 보시면 록타이트 5로 시작하는 그 액상 가스켓들이 시간이 지나도 그 누설이 없이 20바에서 80도, 그 다음에 41바에서 그 룸 템퍼러처 조건에서도 큰 문제가 없다라는 것을 보실 수가 있습니다. 네, 그래서 이 3가지 제품이 있고요. 아래에서 보시는 것처럼 각각의 제품이 온도가 또 다릅니다. 200도, 150도, 점도 이렇게 다 다르고요. 아마 고객사가 사용하시는 플랜지 디자인에 대한 고민들도 많이 하실 겁니다. 저희가 1층에 부스가 있거든요. 이제 있다 보니까 록타이트를 이미 알고 오셔서 어떤 디자인을 해야 되는지, 어떠한 제품을 써야 되는지에 대한 고민을 하고 계신데, 저희가 플랜지 가스켓 쪽에서는 워낙 오랜 전통을 가지고 있기 때문에 간혹 저희가 플랜지 디자인을 어떻게 해야 되는지에 대한 가이드라인도 있습니다. 예를 들어서 볼트와 볼트 사이의 직경 간격은 어떻게 해야 되는지, 못따기의 구조는 어떻게 해야 되는지, 그 다음에 조도는 어떻게 해야 되는 것들이 굉장히 디테일하게 되기 때문에 록타이트가 아마 유일하게 단순히 접착제만 파는 게 아니라 실제 저희의 고객사를 이해하고 어플리케이션을 잘 이해하고 있다는 점이 타사 대비해서 압도적으로 우수하다고 말씀을 드릴 수가 있을 것 같아요. 네. 또 하나는 이제 지금까지 말씀드렸던 것들은 이제 고압 실링을 어떻게 유지할 거냐, 그 다음에 수소가 이제 누설되는 것을 어떻게 막을 거냐에 대해서 말씀을 드렸는데, 나머지 2개 슬라이드는 이제 퓨얼셀과 일렉트로라이저에 대한 부분입니다. 퓨얼셀 같은 경우에는 이제 최근에 저희의 고객사분들의 특히 BPP 본딩, BPP 본딩의 소재 자체를 금속으로 사용하셨던 것들을 최근에 카본으로 변경하는 추세로 알고 있고, 그러한 경우에 있어서 접착제 실링을 요구하시는 경우가 있는데요. 그 카본으로 바뀌는 과정에서 그 누설되지 않게 접착 성능과 더불어서 일종의 가스켓처럼 저희 제품을 댐처럼 쓰시는 경우들이 많이 있습니다. 그래서 이러한 경우에 접착 성능을 낼 수 있느냐, 이러한 것들이 저희가 NDA에 이제 이루어져서 특정 고객사와 함께 하고 있고요. 아무래도 고객사가 이제 패턴을 어떻게 잡을 건지, 접착 라인이나 아니면 양을 얼마나 할 것인지에 대한 부분들은 저희가 같이 진행을 하고 있고, 유수의 몇 개, 여러분들이 아시는 그런 PPP 본드하고도 같이 지금 일을 하고 있습니다. 특히 이제 특정한 거는 이제 카본 자체에서 저희가 여러 가지 고객사마다 상황이 좀 달라요. 물론 면적도 다르고 그 서브스트레이트, 그 소재에 따른 그 성능도 좀 다른데, 저희가 잘하는 게 접착제 종류가 엄청 많습니다. 그러다 보니까 고객사가 직경화 타입을 원한다, 속경화 타입을 원한다, 점도는 낮았으면 좋겠다, 높았으면 좋겠다, 그럴 때마다 적재적소에 저희가 추천드릴 수 있다는 점이 타사 대비해서 압도적으로 우위에 있다고 말씀을 드릴 수가 있을 것 같고요. 또 하나는 이제 일렉트로라이저, 그 수철의 전해 물질 같은 경우에 최근의 이슈는 KOH와 같은 알칼리 제품들, 그런 알칼리 용해제 같은 것들이 온도가 한 80도 내외까지도 올라가는데, 이러한 것들이 기존에 있었던 가스켓이라던가 파이프 실링제 같은 것들에 어택을 가하는 게 문제가 됩니다. 그래서 저희 록타이트 제품은 그러한 알칼리, 그 다음에 고온 상태에서도 어택을 받지 않는, 그래서 그러한 걸로 인해서 여러분들이 자동화까지 하실 수 있는 솔루션을 가지고 있습니다. 그래서 에폭시 계열이나 폴리아크릴 계열들의 제품을 추천을 드릴 수가 있고요. 이러한 제품들을 지금 1층 이제 부스에 내려오시면은 실제로 보실 수가 있습니다. 이제 제가 설명드린 건 여기까지인데, 최근에 이제 접착제라고 하게 되면은 하이드로젠, 특히 수소 쪽에서는 이제 이게 케미칼이니까 조금 불안하지 않냐라고 말씀을 드리는 경우 되게 많은데, 저희가 2가지 측면에서 압도적으로 우위에 있습니다. 첫 번째가 접착제나 실런트 관련해서는 저희가 전 세계적으로 압도적으로 1위 브랜드입니다. 그래서 얼마 많은 케이스를 확보하고 있고 얼마 많은 데이터를 증빙할 수 있느냐, 그런 점에서 믿고 맡기셔도 될 것 같고요. 두 번째는 화학 제품이 옛날에 이제 옥시 사태 이후로 굉장히 컴플라이언스 측면에서 좀 이제 위험한 부분들도 많고 걱정되는 부분들이 많은데, 저희는 그러한 케미칼, 그 다음에 저와 같은 기술부와 같은 전담 팀이 있습니다. 그래서 포뮬레이션이라던가 수출과 통관, 이런 것들에 있어서 훨씬 더 우위에 있습니다. 그래서 여러분들이 록타이트를 사용하게 되시면 엔드 유저한테 사용을 하시거나 아니면 고객한테 어필하실 때 저희의 브랜드를 적극 이용하실 수 있다는 점이 타사 대비 밸류 포인트다, 이렇게 말씀을 드릴 수가 있을 것 같아요. 네, 제가 준비한 건 여기까지입니다. 네, 감사합니다.
네, 감사합니다. 수소산업의 안전성과 그 성능을 좌우하는 핵심 기술 요소로 접착제의 그 중요성과 필수 요건에 대한 인사이트를 주셨습니다. 네, 계속해서 글로벌 시험 인증기관 튜프슛 코리아에서 준비한 발표입니다. 허문범 팀 리더께서 발표를 해 주시겠는데요. 큰 박수 부탁드립니다.
예, 안녕하십니까. TV슈드 허문범입니다. 앞에 이름에 오타가 나 있던데 제 이름은 허문범이고요. 그 TV슈드 코리아에서 그 GS 그린 에너지 서스테이너빌리티 팀 팀장을 하고 있습니다.
먼저 제가 발표드릴 내용은 수소 충전소 성능 평가 장치 사례 및 그 규정에 대한 국내외 규정에 대한 차이를 좀 설명을 드릴 거고요. 이게 필요한 이유는 수소 충전소가 많이 설치가 되고 있는데 이 수소 충전소가 과연 차량 입장에서 안전하게 내 차를 충전할 수 있는지, 그리고 내 차에 이제 데미지를 입히지는 않는지, 그런 것들이 되게 크리티컬하게 고민을 하고 있습니다. 특히 차량 제작사에서 고민을 하고 있습니다. 목차는 다음과 같고요. 혹시 제가 조금 불편한 얘기를 드릴 수도 있는데, 그건 좀 KGS가 좀 불편한 얘기를 들을 수 있는데 좀 참아주시기 바랍니다. 예, 저희 회사 간단하게 먼저 소개드리면 TVC도는 약 한 150년 전통의 역사를 가지고 있고요. 글로벌하게 한 26,000명 정도 일을 하고 있습니다. 그리고 뭐 특별하게 TIC 컴퍼니라고 국내에 계신 분들은 잘 모르지만 유럽에서는 우리나라의 KGS, 뭐 KTL, KCL 같은 이런 역할들을 하고 있는 회사다라고 간단하게 알아주시면 될 것 같습니다. 저희가 글로벌하게 웬만한 곳엔 다 지사가 있고요. 저희가 같이 일하는 하이드로젠 그룹에 뭐 몇십 명의 리더들이 모여 있고, 그리고 하이드로젠을 일을 하는 사람들을 다 합치면 한 몇백 명 정도 같이 일을 하고 있습니다. 회사 소개는 최대한 빨리 넘어가도록 하겠습니다. 저희가 다루고 있는 그 밸류 체인들은 저희가 수소 생산부터 소비, 사용까지 이렇게 처리를 하고 있고, 그리고 최근에 좀 다들 관심 있어 하는 그린 수소에 관련해서는 저희가 뭐 다른 사람들이 이렇게 얘기를 하시는데, 그린 수소 썰티의 뭐 할아버지격이다, 그렇게 얘기를 하고 있습니다. 썰티 하이가 맨 처음 시작할 때부터 저희가 파운데이션 그 파운더로 참여가 됐었고, 한 10여 년 전부터 CMS 70, 그리고 요즘 최근에 나오는 블루수소에 관련해서 블루수소 블루 암모니아에 관련해서도 CMS 77이라는 규정을 만들어서 하고 있습니다. 뭐 저희가 뭐 이런 일을 하고 있다라는 얘기고요. 생각보다 많은 리스크 어세스먼트나 뭐 투자하는 컨설팅이나 인증이나 이런 일들을 하고 있습니다. 먼저 간단하게 말씀드리겠습니다. 본론으로 들어가서 말씀드리겠습니다. 먼저 HRSTA라고 하는데, 코드에는 HRST라고 하기도 하고 수소 충전소 평가 장치라고도 합니다. 저는 그냥 간단하게 평가 장치라고 지금부터 계속 언급하도록 하겠습니다. 평가 장치란 무엇이냐? 평가 장치는 수소 충전소가 안전성과 성능을 입증하기 위한 평가 모사 장치고, 차량에 충전을 해봄으로써 과연 이 충전소가 제대로 충전하느냐를 알 수도 있지만, 실제로 얼마만큼 정확하게 그래프를 그려가면서 데이터를 얻어가면서 평가를 하기 위해서 차량을 대신하는 장비다라고 생각하시면 됩니다. 그러면 이게 왜 필요하냐? 수소 충전소를 차량에 수소를 충전할 때 그냥 넣는 게 아닙니다. 그냥 넣는 게 주유소에서 그냥 기름을 흘려 넣는 그런 게 아니라, 실제 우리가 목표하는 압력, 목표하는 속도, 목표하는 온도가 다 정해져 있고, 그 테이블에 따라서 충전을 하게 됩니다. 그래서 저희가 그 코드를 SAJ260하나라는 프로토콜에 따라서 충전을 하게 되어 있고요. 그 프로토콜을 얼마나 잘 지키는지를 검토하는 장비가 HRSTA 검사 장비라고 보시면 됩니다. 그리고 저희가 보통 충전소에 가시면 주유를 하시면은 주유 계량기에 몇 년도에 얼마만큼 검교정이 되었다라는 딱지가 붙어 있었을 겁니다. 그런데 수소 충전소에서 그런 거 보신 적 있으십니까? 없습니다. 지금까지는 그게 얼마만큼 충전되는지 수소 충전소 내에 있는 유량기에서만 측정을 하지, 실제로 얼마나 충전되는지를 알 수가 없는 겁니다. 그래서 이 평가 장치가 그런 충전량에 대해서까지도 확인을 하는 그런 장비들이 있습니다. 먼저 간단하게 시스템 개요를 설명드리겠습니다. 시스템 개요는 이렇게 되어 있는데, 수소를 충전받아서 여러 가지 밸브를 통해서 유량계통하고 탱크에 넣어서 저장하는 걸로 되어 있습니다. 실제로는 차량이랑 똑같다고 생각하시면 됩니다. 대신에 좀 빼내기도 빼내야 되고, 안에 계측 장치도 많이 설치되어 있다라고 보시면 됩니다. 그리고 그러면 이게 우리가 평가 장치가 뭔지 알았으니까 이게 코드들이 어떤 코드들이 있는지 보겠습니다. 먼저 한국에서는 KGS 코드라는 게 있습니다. 다들 잘 아실 거고요. KGS 코드에 수소 충전소에 대해 지켜야 되는 규정이 있고요. 그리고 국내 국제 규정에서는 ISO 19880-1이나 SAE J660 규정이 있습니다. 각각에 대해서 설명드리도록 하겠습니다. 먼저 한국 내 규정입니다. 한국 내 규정은 올해 5월달부터 시행이 되었고 수소 충전소 여기 그 고압가스 안전관리법 시행규칙 영어로 다 써놨는데 한국말로 써놨습니다. 에 보면 아티클 2에 충전 안전 성능 평가 장치라고 할게요. 평가 장치로 정의가 되어 있고 이 충전소가 꼭 테스트 돼야 된다라고 정의가 의무화되어 있습니다. 근데 그럼 지금까지 지어진 충전소는 어떻게 하냐? 다 평가를 받아야 됩니다. 평가를 받는 대신에 같은 규격의 충전 설비, 같은 메이커가 한 같은 로직으로 돌아가는 충전소는 다른 충전소가 시험받는 것도 인정해 준다라고 예외 규정을 두고 있습니다. 그러면 그냥 막 아무 때나 우리도 뭐 평가 장치를 만들어서 충전할 수 있느냐? 그건 안 됩니다. 그 평가 장치가 지켜야 할 조건들을 이렇게 규정을 하고 있고요. 예외 규정들을 규정을 하고 있습니다. 이 모든 세이프티 밸브, 디텍터, 게시 이런 것들 장비를 갖췄을 때 충전을 할 수 있고요. 이런 설비를 갖춘 기관은 예전에는 여러 군데가 있었지만 지금은 공식적으로 테스트를 할 수 있는 기관은 한국가스안전공사 KGS가 유일합니다. 한국 규정에 대해서 조금 더 말씀드리겠습니다. 여기 보시면 신설 25년도에 신설이 됐고 특례 기준에 따라서 계량 및 평가 장치를 이용하여 확인한다. 우리나라 현행법에서는 KGS 코드를 호출해서 KGS 코드를 따르라고 되어 있기 때문에 실제로 법과 같은 효력을 발휘하고 있습니다. 그리고 국제 코드입니다. 국제 코드는 ISO 19880-1에 이런 제너럴한 조건이 있고 appendix J에 지금 어떤 조건으로 시험이 되어야 된다는지 이런 것들을 규정을 하고 있습니다. 각각의 코드나 규정에 대해서는 스터디를 저희가 깊하게 해봤고요. 어떤 차이가 있는지를 알려드리면 짧게 말씀드리면 국내 규정은 약간 가스 안전공사가 만들다 보니 세이프티에 관한 요구사항이 좀 많은 편입니다. 그리고 ISO 스탠다드의 경우는 조금 명확하게 규정을 하기보다는 약간 두루뭉실하게 이것도 해야 된다 저것도 해야 된다 이건 하지 말아야 된다 이렇게 규정하고 있는 것들이 되게 많습니다. 이런 차이가 있습니다. 그래서 조금 더 디테일하게 말씀드리면 국내 기준 같은 경우는 아까 말씀드렸던 가스 안전공사가 만들다 보니 안전에 되게 초점을 주어지고 있고 인터내셔널 규정은 안전도 안전인데 너네 성능도 지켜야 된다 이렇게 얘기를 하고 있습니다. 그러면 국제적으로 이제 다른 나라들은 어떻게 하고 있는지 한번 보겠습니다. 먼저 한국입니다. 한국에서는 KGS에서 지금 평가 장치를 만들어서 이용을 하고 있고요. 그 전에는 현대자동차도 있었고 다른 회사들도 이렇게 평가 장치를 만들어서 운영을 했었습니다. 근데 실제로 지금까지 평가 장치를 이용해서 평가를 공식적으로 받은 충전소는 없습니다. 지금 현재로서 차량을 한 대를 보유를 하고 있고요. 나중에 계속 제가 KGS 확인해 보니까 2대인가까지 수량을 늘려나갈 생각을 하고 있습니다. 그리고 지금 수소 충전소 성능 평가를 하기 위해서 수소 충전소 운영 사업자들과 협의를 하고 있는 것으로 알고 있습니다. 저희 같은 경우에는 KGS와 협약을 통해서 KGS 이 장비를 좀 써서 이제 국내는 불가능하겠지만 해외 충전소에 대한 평가를 한번 해보려고 준비를 하고 있습니다. 지금 이 장비 같은 경우는 약 20kg까지 테스트가 가능한데요. 지금 상용차 같은 경우에는 훨씬 더 많은 충전량이 있기 때문에 아마 좀 더 디벨롭이 돼야 되고 그리고 모듈화가 된다든지 용량이 커진다든지 하는 개선점이 분명히 있어야 될 것 같습니다. 타이완입니다. 타이완 같은 경우 저희가 이 장비를 이용해서 평가를 타이완의 1호 수소 충전소가 얼마 전에 준공이 되었는데 저희 그룹에 그 영국에 있는 분들이 여기 사업에 참여를 해서 안전성 평가를 진행을 했었습니다. 이 수소 충전소 이 장비 같은 경우에는 약 350바 리시버를 적용해서 350바 차량을 충전하는 것에 대한 모사를 해서 시험을 했었고요. 그리고 시험 결과가 처음에는 조금 뭐 좋게 나오지는 않았었는데 처음이다 보니까 그랬던 거고, 그 문제를 다 해결해서 지금은 타이완에 있는 충전소에 대한 안정성을 충분히 검토하고 합격을 한 상태입니다. 다음 미국입니다. 미국은 인터넷에 조금 찾아보시면은 금방 나오는데요. 지금 하이 스텝이라고 하는 곳에서 지금 만들었고 좀 상당히 오래됐습니다. 상당히 오래됐고, 근데 최초에 만들다 보니까 뭐 여러 군데 지금까지 막 사용을 했었고, 그리고 이게 되게 특이한 게 뭐 예전에 우리도 현대자동차에서 이걸 보고 비슷하게 만들긴 했었지만 이동형 트레일러에 설치돼서 프로토콜 충전을 하고 뭐 끌고 다니면서 충전을 하고 테스트를 하고 했던 그런 경험이 있습니다. 주로 캘리포니아에서 사용을 했었고요. 다음으로 영국입니다. 영국은 조금 특이한 게 있습니다. 얘네들은 충전 프로토콜, 그러니까 충전 압력, 속도, 유량을 체크하는 것도 되게 중요시했지만 유량, 그 충전 양이 얼마인지를 조금 확인하는 데 포커스를 두었습니다. 지금 설비는 이렇게 되어 있고요. 설비는 이렇게 보시는 것처럼 되어 있고, 벤트 스틱이나 이런 안전거리나 이런 것들도 규정이 되어 있고요. 지금 되게 흐려서 잘 안 보이긴 하는데 유량계가 설치되어 있고, 그리고 중량식으로 무게를 재서 실제로 4kg을 충전하면, 수소를 4kg을 충전하면 진짜 4kg 맞아? 라고 확인을 할 수 있는 그런 장비가 있었습니다. 이것 역시 저희 TV시드 영국에서 TV시드 UK에서 같이 협업을 해서 만들었었고요. 지금 이것도 저희가 레퍼런스를 다양하게 가지고 있습니다. 마지막으로 일본입니다. 일본은 뭐 실제로 수소 충전소 저희보다 한때 많을 때도 있었고요. 뭐 지금은 저희가 다 많습니다만은 많을 때도 있었고, 그리고 또 약간 특성이랄까요? 되게 꼼꼼하게 체크를 해 나가려고 하는 게 있었습니다. 그리고 얘네들은 국제 규정을 따르는 게 아니라 일본 내 수소 자동차 충전하는 프로토콜이 따로 있었습니다. 예. 그래서 얘네들 같은 경우는 J260 하나뿐만 아니라 제가 여기 써놨을 텐데, 예. JPEG이라는 프로토콜을 따로 만들어서 JPEG 프로토콜을 추종하는지를 검토를 했었습니다. 좀 부끄러운 말씀이지만 드리면, 우리는 JPEG은 대용량 버스나 트럭에 대한 프로토콜이 있었습니다. 우리나라는 불과 몇 년 전까지만 해도 그런 프로토콜이 없었습니다. J260 하나가 개정되기만을 기다리고 있었죠. J260 하나가 개정되면서 대용량 차량에 대한 수소 충전 프로토콜이 생겼고, 우리나라는 이제서야 그 프로토콜을 추종하고 있습니다. 이런 거 보면 조금 기초과학이나 충전 방법이나 이런 데 대해서 투자나 연구가 더 많이 되어야 된다는 걸 절실히 느낄 수 있습니다. 테스트 이퀴먼트는 보시는 것처럼 생겼고요. 대신 특이한 게 이제 트럭에 실어서 다니는 형태로 되어 있습니다. 어느 게 더 편한지는 뭐 운영하는 방안에 따라 다르겠지만 제 생각에는 이것도 나쁘지 않은 것 같습니다. 뭐 트레일러로 만들면 트레일러를 이제 차량으로 인식을 하기 때문에 그런 것들이 좀 수출입에 문제가 있고, 이런 형태로 만들면 어디 간단하게 옮겨지거나 컨테이너 안에 넣어서라 이렇게 옮길 수가 있기 때문에 테스트하는 데 훨씬 더 테스트 비용이나 물류 비용을 줄일 수 있지 않을까라는 생각을 하고 있습니다. 마지막입니다. 결국 이 수소 충전소 평가 장치를 어떻게 해야 될까? 제도화해야 된다. 그리고 실행을 해야 된다. 저희가 아까도 말씀드렸지만 불과 올해 5월달에 이게 제도화됐습니다. 올해 5월달에 이미 수소 충전소 평가 장치는 엄청 많이 있었지만요. 빨리 해야 되고요. 그리고 이거의 인식을 좀 개선해야 됩니다. 이게 저희가 매번 뭐 한다 하면서도 이거 위험한 거 아니야? 위험한 거 아니야? 뭐 이런 거 하면서 내가 책임지기 싫다 뭐 이런 걸로 해서 되게 터부시하는 경향인데, 그런 인식들을 다 개정해서 인식들을 바꿔서 빨리 진행을 시켜야 하고요. 그리고 저희가 아까도 말씀드렸지만 그 4kg 넣었으면 4kg가 들어가야 되는데 뭐 그런 소비자의 불신도 해소해야 하고 그리고 위험하다는 불신도 해소를 해줘야 됩니다. 수소 산업 하시다 보면 그 위험하다는 인식이 제일 문제가 되니까요. 그리고 마지막으로 제가 그 일본 케이스를 들었었는데 충전 방법이나 충전 평가 장치, 프로토콜 이런 데 있어서 저희가 조금 더 리더십을 가지고 표준을 선도하는 그런 연구 개발이 진행되어야 합니다. 제가 준비한 건 여기까지입니다. 감사합니다.
네, 감사합니다. 튜프슛 코리아 허먼범 팀 리더님의 발표 함께 만나보셨습니다. 네, 다음은 글로벌 모빌리티 기업인 OP 모빌리티가 제시하는 H2파워의 솔루션입니다. 네, 실반 토렌트 아시아 매니징 디렉터께서 수소 기반 에너지 전환과 미래형 이동 수단을 위한 핵심 기술을 중심으로 발표해 주시겠습니다. 큰 박수 부탁드리겠습니다.
Thank you. So good afternoon, everyone. So I'm the last presenter of the day, so I will try to be fast. What I would like to talk about today is about industrialization of our hydrogen storage solution at OP Mobility. Let me first present you our company. OP Mobility is the global tier 1 supplier. It's a French company, family-owned company, actually doing close to 12 billion euro revenue, around 40,000 employees and 150 plants all over the world. And we are actually top 27 in terms of worldwide ranking tier 1 OEM. If we look at our global product portfolio, actually we have 4 main business groups. Those 2 business groups are organized on one hand with our exterior offer, on the other hand with our powertrain offer. The first 2, I would say, bubble that you see, the first business group, exterior and lighting, we are number 1 in the world in terms of bumper manufacturing, number 1 in the world in terms of front-end module manufacturing. Now, if we move to the powertrain offer, we are actually doing fuel tanks through our business group C-Power, and we are also number 1 in the world with actually the E-Power, actually BG, which is also part of this C-Power BG, doing also battery systems. And then today I will talk about the H2 Power 1, which is actually doing the hydrogen storage and fuel cell systems. Those are our 2 main products. And actually myself, I'm the head of Asia for H2 Power. How do we envisage today the hydrogen mobility? Of course, our main target is to focus on the zero emission mobility, and we think through our product portfolio we are addressing this zero emission target. Of course, for us, and clearly what we see in Asia, and especially with the big focus we have in China, we see also the hydrogen energy as a key solution for long range and heavy duty transportation. And then we think also the hydrogen storage will be the enabler, of course, with the fuel cell system for this hydrogen mobility vision. If we think about our 2 different product offer, I will just start by the fuel cell. We are actually having a fuel cell system product team working together with our joint venture with ElringKlinger, EKPO, providing fuel cell stack. And we are integrating this fuel cell stack in our fuel cell system in terms of range of offer. You can see we are able to provide 50 kilowatt and 170 kilowatt, mainly for heavy duty application. In terms of fuel cell system, actually we have 1 display on our booth. But today this is not the topic of the discussion, but just for you to know that we are also providing such type of product. If we talk about hydrogen storage, of course, our main offer is based on Type 4 hydrogen storage. Type 4 tank alone, Type 4 tank, of course, integrated in system, and different type of system for all type of mobility and non-mobility. And when we talk about mobility, on-road and off-road application. If we talk about our product portfolio, we are going from small to large tank, as you can see, from 26 liter to 415 liter. Actually, the large one, the 415 liter, is R134 certified in our plant in France, 700 bar, for mainly heavy-duty application. But we are having a wide range of tank. As you can see, there is a 390 liter, 350 bar that we are developing especially for the Chinese market. And having, for example, the 175 liter, 700 bar that we are delivering, for example, for train applications such as CRRC. From then all the different size of tank. In terms of system, we are actually we have already developed different type of system for truck, for bus, for light duty application, for train, for passenger car. As you can see, with different capacity in terms of kilogram of hydrogen and different pressure. So meaning that we are today able to provide different type of system. And actually, the idea is not to develop always new vessel. Of course, we have our product portfolio of vessel, of tanks. But the idea is that we are able to develop specific system that are, I would say, matching with the different customer requirement from passenger car to truck. Of course, in terms of technology focus, we are validating the design through simulation, of course, predicting all the durability tests, and after confirming through a real test. We are also having a specific focus on components selection. On our side, the main focus, of course, is on OTV, on tank valve, but not only. In terms of production control, also a big focus on our PS, production execution system, to ensure safety and traceability. And actually, the good things at OP Mobility, we are having a long experience in the automotive industry, and we are reusing really the best practices from automotive high volume industry for our hydrogen tank production line. Certification to global standard. Of course, we have to work with all the different standards depending where the customer is located, from, of course, R134 in Europe, KGS in Korea, of course, KHK in Japan, PESO in India, GTR13 in US. So we are having also these experiences in our team to deal with the different standards. And of course, continuous monitoring. I guess we've got an award quite recently. Actually, it was yesterday, and you can see the product on our booth, focusing on, I would say, a lifetime warranty and how to detect any lifetime issue or quality issue during the lifetime of the product. In terms of industrial capabilities, you can see a picture of our La Chelle plant. The difference, I would say, at OP Mobility is that we have really developed a fully automated production line. Of course, that is fully flexible and able to produce different size of tank, from small to large, and The good thing is here we can see the line is made block by block, and we are able to scale the market volume in a short time, meaning that from low capacity we just invest the minimum in terms of capex, and able to add and to increase the capacity of the line by adding a different block on our line. I will come right after on those different blocks. Of course, through our production execution system, we are able of course, to trace all our product. And what is important to say, we have developed in-house, of course, the liner blow molding technology as well as the winding technology. So we are doing in-house the winding machine, which is for us, we identify them as our key process step that we want to keep in-house. And we are having a central team in Europe that is supporting all the region all over the world in order to help us in all the industrialization of those lines, especially in Korea. 3 plants in operation as of today for high pressure storage system, Korea, China, and France. In terms of production step, as you can see, if we talk about vessel, from material feeding and blow molding, so we are using the blow molding technology. It's coming from our experience that we have through the fuel tanks business. I know that most of our competitors are using mainly injection, but we have decided to go to blow molding through annealing, milling, and both assembly. Winding and curing, I would say, is the central or the core part of the process. And then waterproof valve assembly and gas leakage. And we have developed equipment doing gas leak test using hydrogen or helium. We are able to do both. As an example, in China, the GB certification imposes helium gas leak test, which is not the case in other countries, and then developing after the burst and the cycling equipment. In terms of high pressure system assembly, as you can see, we have also developed a standard line in order to assemble the component and do the proper gas leakage before delivery to our customer. I gave you this example. This is coming from our China plant in Shanghai. Some use cases in motion, just to insist on one or two. For example, we have developed system for truck and bus with VDL in Europe. We have developed also storage system for Alstom for train. We have also developed a storage system for tram with CRC. Those one are in operation actually in Malaysia. And we have recently also delivered a storage system for truck for XCMG in China. What really is important for us, and if we talk about our strategic roadmap, is really, of course, to support our key customer, whether they are in China, Korea, Japan. I'm insisted really on those one because I'm representing Asia and insisting on the fact that we need to have engineering team able to deal with the different type of certification that we are facing. But obviously we want to expand our product portfolio from vessel to system, but also from mobility to non-mobility segment. Especially we are also right now studying stationary application as well as H2 transportation application. And then for me, what is the most important, we have this capacity to ramp up our production line quite quickly as soon as the volume will come. And this is something that we have already scheduled and designed from the beginning when we have actually engineered our hydrogen tank production line. Future outlook, as you know, we are right now having a big focus on Asia, and we think that still there are still some regions with strong policy support. As you know, Korea and China. Hello, hello. Hello, hello, hello. Yes. And then we are having actually through our joint venture in China, we are also part of this ecosystem. The government has announced by 2030 a target of having 500,000 fuel cell vehicles on the roads. So as you can see, there is still a strong momentum in hydrogen. Of course, we will wait for the hydrogen policy coming next year in China, and Korea is also still having a strong master plan with heavy subsidies on passenger car and on buses. So for us, we are really focusing on those regions with strong policy support, as well as the key customer linked to those regions. I will finish on the closing message. You can see this is our Wonju plant in Korea. Really, the target for us is to build the backbone of hydrogen mobility through our hydrogen tank product portfolio, proposing as well storage solution not only for mobility but for non-mobility sector, and also able to roll quickly our Type 4 high pressure vessel offer as soon as the volume will scale up. Thank you.
네, 고맙습니다. H2 파워 솔루션에 대한 발표 함께 만나보셨습니다. 이제 마지막 발표입니다. 네, 캐나다 자연과학공학연구위원회 미카 블리종님께서 발표해 주시겠는데요. 주제는 2025 리얼리티 체크, 수소경제 전환을 가르는 결정적 시점입니다. 네, 큰 박수 부탁드리겠습니다.
감사합니다. 안녕하세요. Good morning, everyone. Good afternoon. Good day. I'm glad to be a last-minute speaker to basically provide you with some kind of a wrap-up after these 2 days of exchanges, events, discussions, and whatnot. So basically, this is just a short reality check on 2025 as a turning point year for the hydrogen economy. So basically, I would like everyone listening to this online or in this room to stop talking about a hydrogen bubble that would have bursted. There's no bubble in hydrogen. There's been, in 2023, 2024, at the maximum, a confidence test. But compare it to other industries where there have been some kind of a bubble effectively bursting, you will see that hydrogen is feeling pretty good. So we're talking about a impact on the market from inflation rising, cost of capital rising, high interest rates, lack of liquidity. These factors that have hampered hydrogen development are not endogenous to the hydrogen economy itself. It's coming from the outside. Likewise, permitting delays, normative uncertainties, administrative inertia coming from the outside as well. Actually, what we are seeing in this confidence test of the past couple of years is that only so many actors, only so many factors have been because of the hydrogen economy or the hydrogen technologies themselves. So, in fact, once I've said that, moving on to 2025 and at the end of 2025, today in December, what I can see is that in 1 year, the world of hydrogen has changed like never before. And by this, I mean, this year, we've seen increased interest for low carbon hydrogen, regardless of small or bigger green premiums to get that hydrogen. The reason why that is because the industry is maturing. And as the industry is maturing, what we are seeing is that clean hydrogen is becoming increasingly affordable for end consumers as along the value chain, green premiums at the start is actually shared by all the actors, all the stakeholders along the value chain until the end consumer. And that's the reason why, even if there's like 100% or even 200%, if you like, green hydrogen premium at the start of the value chain, this translates into a only 1%, 2%, maybe 3% max premium for the end consumers at the end of the value chain, making these value chains more and more robust, more and more understood by the whole market, and more affordable. So we are seeing an industry here that of course has gone past the peak of inflated expectations, something that we see in every innovative industry. Doesn't have anything special here with hydrogen. There's now over promises in hydrogen compared to other innovative industries, especially if you compare hydrogen to AI, for example. But anyway, we've passed that peak. And now the industry is back to trying to find what actually its raison d'etre in the global economy is. And as this industry finds its raison d'etre, well, this industry is finding its clients. So in China, in Sweden, here in Korea, but also in India or in Japan, there are a number of geographies, as you can see, in which this hydrogen economy is becoming more and more credible. And so, indeed, this is along a global movement of increased interest for hydrogen. 3 years ago, the first time I spoke at H2 Meet, only 40 countries, 40-ish, 42 in fact, had a national hydrogen strategy. Today, we're December the 5th, 2025, and we've got 121 countries around the world that do have a national hydrogen strategy or who have endorsed a continental hydrogen strategy. So basically, what we are seeing here is that hydrogen is A, here to stay, of course. B, hydrogen is becoming more and more institutionalized. So building policy, implementing that policy, and turning that policy into real industrial development and societal benefits is actually, once again, more and more credible. It is happening. But on top of that, new models, thanks to hydrogen, are emerging. And this is happening in spite of the US leaving the room. This is happening in spite of the US even attacking other countries, other companies, other regions, even if you take the case of the European Union, because these guys have the, how can I put this, dare to invest still in green technologies, and starting with hydrogen here. So China has filled the void opened by the US. India is filling that void opened by the US. Japan, Korea, many other players are filling that void and actually amplifying this burgeoning industry. So at this point, December 2025 again, the global 2030 supply and demand equilibrium is starting to materialize. At this point, we're not talking here about projections. We're not talking about prolonging curves. We're not talking about scenarios. We're talking about firm offtake commitments and firm production capacity investments. What you see here from different sources is that on the production side, we've got roughly 4 million tons per annum of low carbon hydrogen capacity being either constructed, already in operation, or having reached FID. On the offtake side, once again, we're reaching now 4 million tons per annum of low carbon hydrogen firm offtake. So we are reaching a sweet spot here between this supply and demand. The chicken and egg thing is no longer a reality, if I put it in different terms. We are reaching an equilibrium, and that equilibrium is likely to grow because this is, again, quite credible. We haven't had globally ever as much committed investment And by committed, I mean investments, projects that have reached FID or beyond. Once again, projects that are either in construction, already working, or that have reached and passed FID levels. So in 2025, we have globally more than 110 billion US dollars of committed FID plus investments. Just to give you an idea, if we compare low carbon hydrogen to the nuclear industry, for example, the nuclear industry at the end of this year has roughly 70 billion US dollars of committed investments. Hydrogen is way past that. If you want to have more, if you want to grow more, then basically we know what to do. What you're looking at on the left-hand side is a survey that was done by the International Energy Agency. What you're looking at on the right side is a survey that was done by the Hydrogen Council and McKinsey. So two different sources, two different approaches, two different interests as institutions. But two things remain the same. On the one hand, the major factor hampering the hydrogen development globally is regulatory barriers, or call it policy and market uncertainty here in this other survey. And then the second other point is that offtake, missing offtake is a factor, but missing offtake, conversely to what I hear in many hydrogen naysayers rants on social media or in the press, the lack of offtake is not the leading factor in projects not happening in hydrogen. And if we dive into the details, what we see is that for one project globally that got canceled in 2025, 3 new projects have emerged. So once again, the industry is not just rebounding. The industry is definitely becoming more and more robust and credible. And here we have to thank our friends from Korea for that. When we look at a segment like the large fuel cell electric vehicles, large fuel cell electric buses, actually, what we see is that Korea is at the moment the first market in the world to have reached the early adoption threshold in the first half of 2025. In Korea, in the first half of 2025, I'm quite surprised to not have heard this figure during this conference. 1 large-scale bus out of 5 is hydrogen-powered amongst new orders, new sales for FCV buses in Korea. Korea in the lightweight vehicle segment is also doing a lot. Basically thanks to the new generation of the Nexo SUV from Hyundai. What's happened since July is absolutely unprecedented in the hydrogen industry, but on top of that, it was unexpected by market analysts globally, including myself. Let's be humble here. What you see here is the target of the Chinese government for FCEVs in circulation in China for the end of 2025. They were hoping to have 50,000 FCEVs in circulation by the end of 2025 in China. That objective was set in 2020. Did China make it? The answer is no. There's going to be roughly 31 or 32,000 FCEVs in China by the end of this year. But thanks to the success and the whole policy coordination that made the Hyundai Nexo a success, Korea is actually going to reach and go over 50,000 FCEVs in circulation, either by the end of this year or by the end of January 2026, beating China at its own game, so to speak, with a much smaller market. So this is just an example to show you how, you can be a medium-sized country like Korea or like mine. I come from France, so we're kind of the same size, so to speak. And you can be a global leader in something as mainstream as lightweight vehicles, personal cars. But more importantly, policy coordination works. In China, there's different Koreas all around the country fighting each other in this hydrogen business. The Shanghai people, the Beijing people, the Guangdong people, and so on and so forth. In Korea, there's like one country. There's one crowd, one mafia, call it the way you want. But it works. You've got the good size to make it work. And that's the reason why, globally, when I compare now, end user retail pump price on average, what I see is that Korea is, at this point in 2025, the best country in the world. And that's the reason why there's more than 50,000 FCEV in circulation here in Korea by the end of this year. This is not luck. This is coordination, commitment, execution, control of the execution, and it is happening. But don't get me wrong, China is, of course, going to develop even further this hydrogen economy with the 15th five-year plan going into motion next year all the way to 2030. And of course, their market size, pretty much like India as well, will have a big impact on how the industry moves forward. But this is more than a threat, as we often see it in Europe or Canada. This is a market opportunity for Koreans, for Europeans, for Chinese, of course, for Canadians and so on. Because what we are seeing with results from Korea, from India, from China, and other countries is that we have entered a time in this industry where replication and end-to-end capacity, key success factors for this industry to move forward, are actually becoming real. On the production side, on the transportation side, on the storage side, on the manufacturing side, on the project development side, but also on the demand side. And even when Donald Trump comes in and says, well, I'm going to kill this International Maritime Organization net zero framework, on which the hydrogen economy was so dependent in many, many countries, including Korea, to develop, for example, liquid hydrogen value chains, or to develop hydrogen engines or hydrogen shipbuilding. Well, the world is saying, and has said since October, it's okay. Even if you try to kill this, Don, we're going to still invest in hydrogen because we don't have another choice. So it's still moving forward. And there's a final thing I want to mention that will be my conclusion, Madam Moderator, don't worry. It's a new kid on the block, so to speak. Natural hydrogen or geologic hydrogen, I'm sure everybody in this room have heard these terms. But maybe not a lot of people in this room understand how big of a game changer that could be at local level. Natural hydrogen is unlikely to be the next natural gas, in the sense that we would export natural hydrogen like on an intercontinental basis. However, if you have natural hydrogen nearby, let's say within 100 miles radius, then you could have the most efficient, both climate-wise and economics-wise, the most efficient route to get hydrogen to your economy. So definitely, I'm not going to dive into how natural hydrogen is produced and how you could leverage it. Maybe we're going to talk about that next year. But what is important is just to tell you that at this point, this is a fast-growing segment of the hydrogen economy. Almost nobody has talked about that at this conference. Almost no exhibitor downstairs actually exhibits solutions for this segment. But I guess that next year, we're going to turn that into something major. Because indeed, for an island, at least energy island, like Korea, natural hydrogen can be a game changer on many, many aspects. So personally, I think that we should not repeat here the same mistakes as in green hydrogen. We should not maybe oversell it. We should not say that it will change everything, but this is a major thing to consider, especially on an energy island like Korea. I've created this year, together with our Brazilian friends and stakeholders from 7 other countries, the International Natural Hydrogen Alliance, which is an NGO. We launched that at COP last month in Brazil. If you're interested, just join us. It's free, but it will have an impact. So in 1 year from now, the world of hydrogen will have changed furthermore than what we've seen this past year, and definitely take a look at the 6 major psychological thresholds reached in 2025 and picture yourself what could be changing even further in 2026. Investments, production, replicable projects, OPEX parity with diesel in at least Korea and China, offtake agreements reaching a sweet spot, and FCEVs making it to the streets for real. So business models are found all across, even in places, in segments that people 2-3 years ago didn't think would actually help hydrogen develop and build a market for itself. So keep your head down. There's going to be hydrogen, not everywhere, but in many, many parts of our lives. Thank you for your attention. 감사합니다.
네, 고맙습니다. 내년에는 어떻게 변화가 될지 더욱더 기대가 되는데요. 천연 수소가 이제 게임 체인저가 될 것이라고 믿어 의심치 않습니다. 네, 이상으로 하이드로젠 딥 다이브 퓨처 투 테크를 모두 마치겠습니다. 네, 수소 산업의 미래를 향한 다양한 관점과 가능성을 공유해 주신 연사 여러분께 여러분 큰 박수 부탁드리겠습니다. 또 앞으로의 기술 방향을 가늠하는 데 도움이 되었으면 바랍니다. 네, 오늘 함께 해주신 여러분 감사합니다.